All right, let's do a check here. You guys should be able to see my words and hear my words, and everything's good. All right. So, what do we do on Sunday mornings? We do labs. And yesterday, you guys asked for basic Linux. That's what the people wanted. So, I'll do basic Linux today. Like intro, like we'll start out and do things. We're going to take notes as we go. Maybe even draw some stuff. Who knows? But helping us to remember and understand things. Hey, Chillin' Spree over on YouTube. How's it going? We are, we're going to do labs today. That's what we do. And if anybody wants to follow along, they can. They're all up on Killer Coda. And give people a minute or two to kind of mosey on in here, and then we'll get going here. And that'll be what we do on Sunday mornings, right? Work on labs. We'll ask ourselves questions. We'll take notes. We have, if we need, the Socratic stuff. Socratic Linux is up here somewhere. Where do I got that? Yeah, so if we wanted to ask ourselves the Socratic questions, we could, which are just like us asking and then figuring out, different pieces of the system, keeping track of our commands. This is up in the Discord if anybody needs it. So if you're like, oh, that's a lot of stuff, we're not going to get through all that today. That's true. It took us a while to do all these, but this is just all kinds of questions and like, can you loop over a list of files? Can you check your current users? Can you check, can we set one variable that is inherited by a child process and one that is not? Do we understand what that is? So this right here, this is kind of a completed set of notes that we did, and we're going to be building new ones today. But these asked us questions about the system. Can you tell me the manufacturer of the chip and all these other things that exist out there? But we'll build our own notes today because for anybody that wants to, kind of make yourself remember things better, there's, a whole bunch of teaching theory on writing it down, right? When you write things down, it helps you remember. So, you type them out, do whatever. So let's get into it. The first lab is going to be just looking around a Linux system. I'm going to take this. I'll pin it for you guys on Twitch. And I'll pin it for you guys over here on YouTube. Actually, I won't even bother pinning it on YouTube. It'll be fine. You guys can see it. We don't get a lot of scroll on the YouTube side, so I'll just leave it there. So how does this lab start? It says, welcome to Prolog Linux. I could even drop this here and say this is the lab we were doing, right? And it says, you are a new system administrator company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. This happens. If you don't think it happens, I would question how long you'd been in any industry, let alone IT, but there's always going to be things that are undocumented within your systems. There's a bunch of things that just get lost over time, or somebody doesn't write them down or whatever. So your job is to go find out about those servers. Even if nobody told you to do this, this is a good skill, because you need to be, from the moment you like land in a system and you start to become either an administrator or like a junior engineer on a system, maybe you don't completely have root yet, you just have some pseudo permissions, you need to be looking around that system and learning what's going on. This is what I do when I land on a system. I just start gathering information for myself about the system. So the question is, you need to figure it out. And it says you find yourself at a command prompt and need to find out what type of system you're working on. So we're going to ask ourselves questions about the release and the version of the system. What is the kernel version? How long's the system been up? What was it booted as? How do we know that grub was what booted it? That's the Grand Unified Bootloader. So you might come over here and say, like, your first note might be something like this, right? You might just say, what's grub? And then your ways to figure that out are to look around in the system and try to figure it out in context. Or you can go look around on the Googles or DuckDuckGo. You can ask questions and this kind of stuff. But now I've got a question up there, something I'm trying to figure out while I'm doing the lab or whatever. It may show itself in the lab, or it may show up later, right? So what's grub, right? That kind of thing. All right. So the first thing I say to do is check what version of Linux on. So we go and we check cat etc splat release, and we see that we're on this Ubuntu 2004. So another question right here, what version are we on? And we know that that is Ubuntu 2004 LTS. And your next question might be, why would I want to know that? Or like, what's the purpose of that? Well, I don't do a whole lot of Ubuntu professionally, but I know where I can go find out information about Ubuntu, and that's Ubuntu on its forums, on their. They've probably got some open issues that I can go look at on GitHub. There's all kinds of things that I can go do, but one of the first things I need to know is what version of Ubuntu are we on. People are still running Ubuntu 18. They might even still be running 16 professionally. There's 20, there's 20, I think there's a 22. I've never seen 22, and then there's a 24, right? But we need to know what version we're on, right? We need to know what's kind of going on within the system to even ask the questions. So I might do something like this. I might come over here and say Ubuntu 20.04.5 LTS, and then lifecycle. Maybe somebody knows, there's probably a blog out there, or maybe even right on Ubuntu, where they tell me, here's the release cycle, so this is good. I didn't know where this was a few minutes ago. And I say, yeah, sure, whatever. And now I can see, okay, there's long-term support and interim releases. What is long-term support? So I'm used to long-term support saying 10 years. This says Ubuntu LTS receives 5 years of standard security maintenance for all packages in the main repository. So that's I didn't know that. I thought it was always 10 years. So now I might go throw that on here, and I can say that an LTS support receives 5 years of standard security maintenance for all packages in the main repository. Now that means that we've got about a year left on Ubuntu 20.04. What does that mean for an organization? For a company, that means unless I'm on their pro subscription, which then expands it to 10 years, okay, if I'm not paying Ubuntu, but I'm using Ubuntu, my organization only has 5 years before I need to be planning to move off. Does that kind of make sense? Like, the life cycle of my servers just went from, I could have 10-year life cycles down to 5. Now, that's definitely more of a virtual machine thing, because what's the life cycle of your physical boxes? Typically only 3 years, right? Physical hardware gets rolled through every 3 years typically. I mean, different organizations do it differently. Some people keep stuff around and use it in their dev environments or whatever, but prod type customer facing things staying under warranty for physical machines tends to be about 3 years. And that's a hardware thing. So, you know, guys that are like, I know people have said like, oh, I want to get into data center work and I want to do some of this other stuff. Those are the type of life cycles you're going to look at, is like, how often do we replace hardware? What's the mean time between failure, and how do we keep our hardware under that mean time between failure as an average? You know, that kind of stuff, right? There's a lot of theory behind all that. So, so you can get to 12 years coverage. So this is what that looks like. 2004, which is the focal fossa, which is what we just found. We've got support all the way to April of 2023 if we're not paying them. If we are paying them, we've got support out to 2028, and then there's this legacy support for 11 and 12. So we could keep a server up to 12 years, theoretically. That's good. And look, this is an important thing to know. So I'm going to take this and I'm going to say this was, you know, something important for me to know about how Ubuntu works. Right? Look at that. That's all the releases, all the current releases. And apparently there's a 22. I guess I just didn't remember. And then 23 is this was a short release, and it was just a little standard security maintenance, and it's not going to be supported. Actually, it's not supported anymore. We're past July. So this is how you go and look this stuff up. There's one of these for all your Red Hats, right? We're not doing Red Hat right now, but Red Hat's big in the industry. There's one of these for SLES, which is the SUSE Linux Enterprise Server. And you got to get in here and understand. And here's the thing, right? You say, well, why would I care about support when I'm the support? I'm the one who fixes my server. Sure. You know, we fix our servers, but we don't write drivers. We don't write security updates. That may be a specialty that you go into later in your career. But if you're somebody who's tasked with keeping 1,000 servers up, you're probably not doing those things on your free time. And that's probably not things you're doing when you're keeping your servers running and working off trouble tickets and then planning new deployments of new services and things and doing security. Because, like, you know, a Linux systems administrator and also a systems engineer, they have a lot of kind of like a wide breadth of tasks that they have to do across the system to keep it running. If you're doing more engineering, you're deploying new stuff and making stuff work, but you're still adhering to the common like Linux system administration type standards of your organization. And if you're a systems administrator, which a lot of people still have a title of systems administrator at some point later in their career, you are just maintaining that fleet of servers going forward under whatever types of standards you have, right? So anyway, so we're doing labs, but we're also talking about stuff and taking notes. That is why this page is so important. Some of you guys might go, Scott's showing that again. This is the 30th time this year he showed us how to do this. It's important, especially for new people. I got asked yesterday. I did a little survey. What do you guys want to do? And everybody, the highest by far was go do basic Linux again. I said, all right. So we get to a system. We've been dropped in. We've never seen this system before. And the first thing we do is check this. Next thing we do, we check the kernel version. What's the version of the kernel that we're on? Because that's going to matter so much for... Man, I made it 10 minutes before anybody even said anything on the Twitch side. That's actually really funny. Hey, Vanny, how's it going? And Saber, how's it going? Yeah, no, you guys should be able to see my voice, yeah. Yeah, I had a comment on YouTube right at the beginning, but then nobody on Twitch for the first 10 minutes, which is super rare. Normally somebody will say something on Twitch. All right, that's fine. So we've got a kernel version. And the reason the kernel version is so important is similar to this, right? Like you're going to have... These are the two things that any support ticket you're going to put in is going to require. They're going to ask you the version and the kernel version. Those are the two things. But let's say you're trying to take this Ubuntu server and you're trying to like maybe put in like... let's say you're trying to put in like a Mellanox M5 card or something like that, right? You're trying to get one of these cards into a Mellanox, and you're trying to see if it works with maybe this kernel, right? And we should see, we should be able to see down here somewhere. Typically you'll be able to get them just to pop up. So they'll have, Mellanox 5 IB, and then these are for the different older Connect X3, and then we've got newer ones, and then you come down here and you can look at, let's open the image in a new tab so it's easier to look at. Here's kind of the relationship between the Mellanox IB that you might run into. We're not too worried about that right now, but that's an interesting drawing maybe if we're having problems. But then we come down here, and it was taken into RHEL 7. We come down here. Sometimes they'll have a matrix. And if they've got a matrix, it'll tell us what different drivers have been tested. Not always. For a thing. I don't see a matrix here. Mellanox 5 maybe. Here's some config settings as you're setting it up. Go look at device links, some commands to make sure that your modules have been loaded. There's all kinds of things that you might have to go spin off and look up. But the point is, you need to know your version of your kernel to even be able to ask those questions right. Because if you go in here and you're looking at some stuff, but it's for a totally different version of the server, it doesn't make any sense to even stay on that page anymore, right? I don't see... Yeah, I normally get it from like the vendor, but they'll have like, let's see if we can get a Mellanox matrix. Yeah, so you get like a compatibility matrix right here, right? Let's see if this will pop up with a little matrix for us. Here's an OFED download page. I consent, whatever. So then maybe, in this case, I happen to be looking for whatever version of, I had been looking for Ubuntu, right? So that should be up here. And they talk about RHEL, SLES, Ubuntu, and the major distributions. And you come down here. It looks like they don't have the, yeah, they don't have it the same as they used to. But down here, I can start to look at, these are kernels here. So this is actually your kernel version right here, right? And then this is your If you have an Ubuntu version, that's an Ubuntu version, right? So, and then this here is, yeah, kernel. So let's go look at our kernel real quick. What's our kernel version? 540131. Right? So we go do this, and then we go pop over here. 540. So 540 is going to be the closest if we have it. And sometimes you have to find something close. Let's say we did this, and then this should be the kernel version here. And then I'll say that I'm on Ubuntu, but I'm on Ubuntu 2204, and then the architecture is x86, and then this would be the version, if that was the right kernel, right? You got to make sure you got the right type of kernel. Mellanox, well, Mellanox has all kinds of cards, but that is an InfiniBand card typically. These type of cards that I'm looking at, they're an InfiniBand card that connects into a high-speed network, right? So there's that. Twisted Seed, how's it going? Yeah, so then, you're over here and you're looking for mapping these things together. And this is, again, this looks like it's pretty simple, but you got to have all the things right. If you can't find the right kernel, then now you might have to put in a request to support, and then they'll be like, oh, yeah, no, that kernel falls under this 543 or whatever. Or just find the one that's closest, which is this one, this 541. And then we're back on Ubuntu, and then Ubuntu 2004, and then x86, and then these are your drivers for that. So my point in showing you guys all this, and then maybe we go here and we say, matrix of Mellanox support is right there. And Mellanox is owned by NVIDIA. NVIDIA bought them a few years back. Actually, you can see it right here. It's network.nvidia that we're on, even though we're on a Mellanox page, right? But it's all NVIDIA now. So then, to take those drivers, you install them to your system. You make sure that your system is seeing your card. There's all kinds of things we could start to do here if we actually had a card physically in the machine. And you might say, well, how would you know? Well, if we knew the name of any of those modules, those kernel modules, we would do an ls mod, and we would look for them. We can do an ls mod with a grep, and we can search for things. So these are all the loaded modules into the kernel right here, ls mod. Then, if we knew that system was going to come up and it was going to be on, whatever bus for the system, we can look in Dmessage. Oops, Dmessage. And then in Dmessage, we might grep for, let's just say it was Mellanox, but it's not going to be, so maybe we just look for ETH, like for Ethernet. And in this case, we would see that something had started, and this is our Ethernet for the system, and here's the two loaded kernel drivers for our system that are important for our virtual networking to work, right? So my point in showing you guys all this is the lab is pretty straightforward and simple, but if you're doing this with me, which by the way, it's linked over on the Twitch side, and then it's over there on the YouTube side, you can come in here and you can find out a lot of stuff about your system. And then I might say, what is the system uptime? And in this case, our uptime is 5 hours and 12 minutes. How do I see that? It's right here. Also, I was kind of taken aback there. That's the longest I've ever seen one of these Killer Coda labs up. One of their lab systems. I've never seen them up more than about an hour and a half. Because what I think they do is they have a pool of them, and they stay up until people use them, and then when people use them, they reboot. 5 hours and 12 minutes means that people probably haven't been using the labs much. So we gotta drive more of you guys to the labs to go check them out. What's the last one? This one's kind of important. How did our system boot? Where did our system boot from? What kernel command line arguments were given? And that's right here. Cat proc command line. As this system was called, as it was booted up 5 hours and 12 minutes ago, this is the image that was called. Here's the image, which maps back to the kernel. And here are the different options that were given. The root is going to use a label for cloud image root fs. We're going to do read-only for that, but then the rest of the system is going to boot according to its etcfs tab rules, and then some console information. There is all kinds of information you can put on a kernel command line There's all kinds of directives you can give to how the system behaves, and like pretty much anything you might want to know is right here. Now for me, thanks for that, Space Pakal. He said awesome content, thank you. Yeah, my goal of this is to show you guys how we build systems out and how we test things. And one of the things I do, and this might seem kind of simple, but if I have like 1,000 servers out there that have been built through a process and I know that they should all be the same, one of the things I do is I will hit them all. I'll use commands like pdish or xdish, which are these, they are commands that will hit a list of servers that you want to. They just simplify like a bash loop, right? And what I will do is I will just check, are all the kernel command lines the exact same? And you say, well, why would that matter? If they're built exactly the same from the same template, if you went like this with a little thing of Play-Doh and got a star out, it should be the same size star every time that you do that with the Play-Doh, right? Like, and that's simple. Most of you probably remember when you were a kid playing with Play-Doh and you had the little thing that could go like that and it could squish out a little star. It's the same idea. All my servers should be exactly the same right here. If any of them are aberrant or any of them have gone a different way, they probably were not built the way that I expect them to be built. So this is a way for me to prove, like sanity check, all my servers were deployed. All right, so where else can we see this? There's also Dmessage. So if we clear the screen and do Dmessage and then just say like head, Dmessage will show you from the time that the kernel was called. That becomes like it's almost like the epoch of the kernel. That starts at 0 now. And then it all the time moves forward from there. But right here you see the kernel command line being called. That directly maps to what we've seen in catproc CMD or CMD line, right? So system's been up 5 hours and 12 minutes. This is the way it was booted. If that is what I expect, continue on with my day. If that is not what I expect, we'll go dig in and figure out why things are busted. So this is the very basics right here, right? This is pinned over on Twitch, and it's also on YouTube if anybody wants to do the labs with me. These are free labs. Killer Coda just gives us a platform, and then I'm the guy who wrote them, and then a bunch of my Prolog guys have helped to edit them and make them better. These are like the basic things. If you were just some new systems administrator and you're trying to find out a lot about some servers that have no documentation. Because I'm going to tell you right now, you're going to come into a server, set of servers, and they're going to be like, you're going to ask, hey, where's our inventory list? And they're going to be like, and you're going to be like, well, where's our documentation on these servers? And they're like, the guy who did it before you's gone. We fired him, or he moved on somewhere else. And you're like, well, who's going to figure this out? And they're like, the Linux server, they're pointing at you because you're the server administrator. You're the guy now. You're the guy or the girl that's got to get these servers working. This is your job. So the very first thing you do is figure out what type of server you're on. All right. I'm not going to tell you have to do that, but that's one of the first things I would do. You might also, if they don't even know where all their servers is, you might ping sweep the network and nmap it just to map out where your servers are and start making sure you have access, right? Maybe they probably got a password list of things to try to get into, or maybe you've got key from your main thing. And the first thing you should do as a new administrator, if the old administrator left and you're the only administrator, everybody know what the first thing you should do? Change all the passwords. Next thing, change all the keys, right? Those are like the first 2 steps. Right? Make sure you're the only one that has the new keys. Make sure you're the only one with the new passwords. Right? All right. So we're going to dig a little deeper in this, and we're going to, my advice always on these is do each command and think about what you're looking at. Get a notepad out over here. I don't care. This is logsec, which is a free tool you could use. Where's he at? I don't know. It's just called logsec. LOGSEQ. Yeah, there you go. You could use OneNote, or this is a Notepad++. You could use OneNote. You could use a simple notepad if you wanted, right? Just have a simple little notepad. This notepad would be kind of bright, but it's also just a simple notepad on your system. Literally every operating system desktop I've ever seen has Obsidian's perfect. And look, I tell you guys all the time, practice your Markdown. Markdown is valuable. You should know how Markdown works for documentation of things and passing that information on, right? But you know, maybe I'm just keeping these notes for the lab. I'm just keeping these notes for the lab. But these are things that would be valuable to me to go document all my servers. We're all on this version of Ubuntu. We found out that they've got a 5-year release. So if we're not paying Ubuntu, we've got 1 more year of support on this. So we got to think about moving off of these now and moving to a new version, which might sound super simple. You're like, oh, you just go and you just rebuild your servers. Yeah, not if people are using them, right? Could you imagine, like, if you were like the car dealership, and the car dealership it sells cars to people, right? And then those people drive off with those cars, and they don't bring the cars back unless they want to, right? Like you have no pull as a car dealership to tell somebody to bring their car back to you. But what if it's still your responsibility to change their oil and fix their stuff up? But they're not going to come in when you tell them to. They come in when they want to. It's the same kind of concept with servers a lot of times. We have to go and, you know, you have hundreds of dev teams working on these things, and they own the servers, but you're responsible for the maintenance of those servers. So now you've got to negotiate with teams, and you've got to plan out when updates happen. This is a whole big thing in organizations. This is a lot of times there's a plan already, but, you know, teams do not like giving up, you know, 1 night a month of maintenance. They don't like doing that. They definitely don't like having that maintenance on their dev teams during the day, 1 day a week or something as well, because now their dev teams aren't working on those servers. So, you know, it's one of these things where you're in charge of it, but you don't own it. It's a strange thing. It's a strange thing being a systems engineer and a systems administrator and running these servers that other people kind of own in the organization. All right, so we're going to dig a little deeper, and we're going to go look at what's going on. So we're going to look at a tool called VMstat, and that is hard to see. So I'm going to pull this over like this. And when we do VMstat by itself, so now we start to take the command apart a little bit. We got VMstat by itself. It gives us one instance, one slice of what's happening within our system right here. And it's a whole bunch of cryptic somethings with a whole bunch of cryptic somethings, right? Who knows what they are. But we go look at this, and we say VMstat 1.5. So now every 1 second for 5 iterations, it's going to give us whatever those things are. And then we're sitting here scratching our head going, what the heck are those? So, a couple ways to figure that out. Somebody can show you what these all mean, or you can read the man page. So you read the man page for VMstat, and it tells you that here are your command line options, so you can change how it behaves. And then down here are the fields. So that R and that B are, R is the number of runnable processes running or waiting for runtime. So how much of our system's sitting here. And then B is the number of processes in uninterruptible sleep. Okay, so R and B, those R and B, right? Like the music. Let's hit Q real quick, and let's run this real quick and see, do we see any runnable processes or any uninterruptible processes going against the kernel right now? And the answer is no. Now, how would we know if that was high compared to this system that we're on, right? Well, there's something that I didn't make you do in this lab, which maybe I should have considering we're looking at this. Do an nproc on your system, and you'll see the number of processors that you're running. This is how many processors exist inside the machine right here. You can also verify this by saying cat proc CPU info, right? And then well, you can just do that, and then you'll see that we just have the one processor here. So over here, maybe I might say how many processors? 1, right? I guess I could put it up there. 1. And how do I know that? We can say nproc or cat proc CPU info, right? And then we would have to do some counting, because depending on the system that we're on. Okay, so I've got one processor, and here I don't have anything sitting here waiting, and I don't have anything uninterruptible. So I would say the system's not really doing all that much. It's kind of chilling right now, right? The system's just going. Then here's swap. Is there any swap? And over here, is there any swapping in or swapping out on the system? In modern Linux, you want that number to always be 0. And you say, well, what the heck's a swap? Swap is when your system is run out of actual RAM, and it's starting to use what in the Windows world is called virtual memory, but in the Linux world we call it swap. And it's taking that RAM, it's taking the additional things that it wants to go put in RAM, and it's putting them on a physical disk. So the speed of things relative in a system is, if you, so let's just say real quick here, as an idea, relative speed of things, right? And when I say relative, I mean relative to each other, right? So a processor is the fastest, right? And a processor operates at a speed, in this, since we're saying relative, a speed of 1. So then you've got RAM, right? So you things only process across the processor, but we're going to go read things out of RAM. So RAM has a relative speed compared to your processor of typically about 1/10 to maybe 1/100th the speed of that processor. Meaning it's much slower, right? So then swap or disk is 1/100th the speed of your RAM. So I just want you to think about this. If you knew nothing else about what I just said there, and I told you that a system was swapping, you would know that for stuff to go across the processor, for instructions that were in memory to go across the processor, if they're all held in RAM, there's a little bit of weight, but that's acceptable because that's part of the system, right? We understand this. But now 1/100th the speed of that RAM is the time it goes and takes to get those instructions back off the disk. That's not good. You like if you were ever swapping in like a database or something, throw the database out. It won't be even useful. Well, if it's a transactional database, if you're doing like transactions that require some type of service level agreement, you'll never reach that service level agreement unless it's like seconds or minutes. Typically with service level agreements on databases, we're talking like small milliseconds, like under 5 milliseconds are the response times. But if you're swapping out to a disk, like a spinning platter disk, no, it's going to be seconds to get data back. And that might sound like, you may be like, oh, seconds. Yeah, when you're doing thousands of API calls a second, you can't have them backing up like that, right? Like in a system. Stoic said, hey, Scott, is there a future for systems engineering? Could you please share the interview process at Mang? What's the pay scale for these roles in big companies? Stoic, I've never been in Mang. I know quite a few engineers that have been through that process. And some of them, like Fisherman, if Fisherman's around, he's one of the guys who he got into one of the big ones in the last couple years. I can tell you, like, I know what the process looked like for him because he came and talked to the group a couple times about it. But I think there's a future for systems engineering because here's the thing. The stuff I'm showing you, like looking at it and hitting the buttons and stuff like that, there's probably like 1,000 AI chat programs that can do, LLMs that you could probably set to run things, and maybe some SIEM and SOAR solutions, like SOAR is your security orchestration, that can go do a lot of the things I'm showing here. But then the back end, like the abstraction of like why they're doing the things, it's not there yet. It's not like what this means to the overall system, and if this is good or bad. I don't think any of the stuff's there yet. So I don't see systems administration going away or systems engineering going away anytime soon. There are good systems for building things and designing them and there's some good like little like co-pilot type programs that'll help you do some of this stuff faster. But like you still have to know how these basic pieces work, I think, Stoic. So the pay scale, yeah, I don't know the pay scale at those big companies either. Every time I turn around, like it's weird. Like I'll see people go on the levels.fyi, and it's like every single like reporting engineer is making $400,000 a year, and I'm like, okay, they're making $400,000 a year or more, right? But then you go and you look at like what's the average software engineer make at like AWS. They publish this, and Google, they publish this, and it's like $95,000 a year. So somebody's lying. There's a big disconnect there between if everybody averages over 400,000 and the published actual average from their company is like 95 to 105 or something. There's a huge disconnect there. Like enough that like most people would go, that doesn't make any sense. Either the only people that report those other things are all principals and those type of things, but then that means that 95 to 105 is actually much lower, because when you're an entry level person and there's so many people dragging up the top of that, that other people have to be dragging that down below 95. So I have no idea, but I just can tell you that the stuff that I see people like, I see people on here going to levels.fyi and everybody's making 100, 400, 500, 600,000 and this and this and this. And I'm like, something's not math in there. Like the math is not mathing right there. So I think systems engineering is going to be there though. And I do it for a smaller company. My company's Redline, who I work for. And then we do government projects, and we're subcontractors to some jobs, and then we're also the primary to some government jobs. And you can do very well in systems engineering. You can do very well in this field still, building out systems. In fact, next week I'm going to be in Austin. I'm going to be in a data center. I've got some networking to set up. I've got some more system stuff to set up. I've got to go crack into a set of servers that we lost access to because somebody had put a password on them that didn't make sense. So I got to go console in and take over the server, right? Like those kind of things are things that, they're always going to need somebody to be able to do that stuff still. So, all right. More information over here. We've got the free memory, the buffer, and the cache. And just at face value here, have we run out of memory on this box? No. There's also a command free that I like to use. Free-m will tell you how much free memory you have. And this is about 249 megs. This is also in bytes here. So that's, that about maps pretty accurately there. There's also the buffer and the cache, which looks like it's about mapped there as well. There's the I/O, and then there's system, and there's some CPU stuff. And again, if you want to go spend time with these, you can go look at the man pages for what all of these mean. But suffice it to say, if we look at this and we don't see anything right here in the R's and the B's, and we still have the one CPU, this system is not under heavy load. There's not a high wait time for resources right here. There are other ways for us to look at the waiting for the usage of like CPU, and the main one I use for that is uptime. And this uptime right here, this is the 1, the 5, and the 15-minute load average of the system. And the load average, you might say, well, what the heck's a load average? Well, load average is relative to the number of processors you have. So if you have one processor, and you have less than one here on each of these, you do not have wait time for more than a second to get to that processor for any process. If you have one processor here and you've got like a load average of like 2 or 3, your system has processes that are waiting to get access to that one processor for greater than a second. That's what those numbers start to mean. But it's relative. Like you might say, well, so is 1 high? Well, anything higher than 1 is high on this system. But if I've got a box that has 32 processors and it's running an average of like 8 over here, that's not a high wait time compared to having 32 CPUs, right? That's a generalization. There's some single-threaded, very bad applications that would only run on one processor, and they could be waiting to get to that one processor that they're waiting for. There's actually a process of what we call pinning to a core, where we can focus a process on just one core. And yeah, if that thing goes over 1, then that thing's going to be waiting for that one core. But that's a different concept. That's not going to come up in one of these general things. That's something you go and look at on a case-by-case basis. So, okay. All right. So anyways, I said, what are you seeing here? Is the system under high memory usage or not? No, we're not maxing out our memory. We're not out of memory, and we're not waiting for the CPU at any given time. So that's pretty good. And then I said, let's go check the overall CPU usage of the system every 5 seconds. So we go look at this, and I'm going to make this just a little smaller here. So if you just looked at that, and you didn't know anything else about this system, you just were looking at this output here, Would you guess that this system was under high load or not? Does this system look like it's under a high load right now? I can tell you right now, yeah, 100% idle. That's probably the most chill I've ever seen a server be, especially during one of these labs. This system's chilling, hanging out. It's not even doing anything. So that's okay. That's good. Like, so I come to the server. It's a brand new server that I built out. Maybe I gave it over to a dev team, and somebody's like, "Hey, are they using that?" Like, the manager comes to you and goes, "Hey, is my team? We pushed really hard to get that today. Is my team on that server yet?" And I go, I mean, I don't see them on it yet. There's nothing there. There's other ways to see if a user's on a system, but I'm saying, like, they're not running any processing on this machine yet. So then we might ask, well, what's running on the system, right? Like, so we see that the system's not doing much, but what is the system doing? So we can do a ps-ef, and that will show you every process that's running on the system. And that's a lot. I don't want to count those. So here's 2 ways to count them. Oh yeah, how would I check if people are on? I would do w who, but specifically speaking in this case, I'm just saying, like, he's asking is the box being used? Like hey, they pushed to get the server built, like, and they went through the, and they talked to my manager and made me build it today, and or they pushed the button and made sure that they had enough resources with our automation team or whatever, and now the manager wants to make sure his guys are on it. Nobody's really doing anything on this box. They might not be logged in, but have they kicked off any processes even? And I would say no, this box is chilling. Box is doing nothing. But what exactly is it doing is the next question, right? And what exactly is it doing is all of these things. And most of these, so there's a whole story that's happening with each of these, but let's look at that real quick. Let's do our PS. So clear. Let's do our PS, and I know that that's going to dump a lot to the screen, so I just want to count how many things are happening. There's 120 things-ish happening on this system, but maybe I want to see them, so maybe I drop a number line to it, and that'll just count them for me as well. There's a new field added to the left over here, and that's okay. But then over here we get some interesting stuff here. We get the process ID. That's how we're going to control a process if we need to kill it or we need to nice it down to like a lower priority. And then we get the parent process ID. And the parent process ID tells us who kicked off the process. So how did it get kicked off? And then that's sometimes useful because we can see that all of these things were started by 2, but some of these things were started by 1, and 1, so the parent process ID is 1, and the process ID of 1 is the S-bin in it, which for the most part is we consider systemd. So systemd is typically the number 1. So we saw that process ID 1 was started off right here by S-bin init, and that is running the process systemd. So systemd is almost always 1. So why would that be relevant? Well, because when I come down here and look for libsystemd and all these things that got kicked off, their parent is all systemd process. So as like a kind of cheap little trick, like a little, somebody says, well, how do I know that a process was started by the systemd daemon? Well, its parent will always be 1 on your system. So why does that matter? Well, now I can go look at these. So like network D, I would expect these things that got kicked off for whatever these are, I would expect these to have been kicked off by systemd, meaning that I should be able to go figure out how they were started. And then I have a whole different lab on like how a system starts up, but I should be able to do like a systemctl. If I do just systemctl by itself, it'll do a thing called list units. This command here will show everything that's on the system. So a systemctl by itself will do that same thing. And let's just look for, so I'm going to just grep the output, which is going to capture this. So this will dump too much to the screen, right? and I'm going to capture that output to the standard out, and I'm going to grep, which will search, right? It's the GNU regular expression processor, and we're going to look for network. And now I see that there are these things that were maybe started, and one that I might care about here is network online target, systemd network D. I should just be able to see the network service. Yeah, there's network. All right, so let's try this real quick. Let's say systemctl status network. Let's do network dash. Well, I guess this one. What's the status of this? Right? We see that it's enabled when the system comes up, and we see that it's currently active running, and it's got a main process ID 394. We should see that it started up. We can see different kind of some message stuff that goes along with it. But then we should be able to see, yeah, it was enabled, it was started. That main process ID of 394, which is the systemd network, we know that that maps back. So if we do ps-ef again, grep-i for systemd network, we should see that, yeah, that 394 maps back to process ID 1 that started it. That's right there. So we can start to figure out like how our system started up, what was going on with it. I can look, there's a bunch of other things we can start to do with it. We can take that systemd network D dot service, and we can start to see how it was started up. So we can come over here and say systemd analyze critical chain, and we can see how that started up from start to finish. There's all kinds of things that we can start to do once we start to kind of understand, okay, this thing's running. Yeah, systemctl is one of my favorite. Like if I want to check out a box, and I have a different lab that shows us how to do this, but I'm kind of showing you guys this stuff. If you were watching this and you were like, hey, you know, this guy's doing a lot of stuff, you could just, you know, start putting in the commands I'm doing. Right, there's all my commands. And then if I were taking notes, I would be like, what's a systemctl? What's is a systemd analyze? Right? What is that? Like, what are these things? And then I would put those in my notes so I can go and look them up later, right? One other thing, this is one of my favorite things to do. Like, if I come to a box, if you say, hey, Scott, this server's just not working right, and I'm like, all right, well, the guy who runs it normally, or my other engineer, or maybe he's gone and now it's mine. I inherited it, right? I want to see how healthily did this box come up. And there's a command that'll help you do that. It's systemctl, right? So systemd is starting almost everything. So you can say, I'm going to list the units, but I want them in the state that equals failed. Is systems more of a daemon service manager? Yeah, systemd runs everything. It starts everything. It keeps everything running. No. So systemctl is our command to access like what's happening. Yes, systemctl is a command that we use, but systemd is the daemon that we're querying, and it's the thing that started everything up. If that makes sense. Now, this system came up pretty clean. There are no busted things here. There are no things that weren't able to start in the system. That doesn't mean there's none failed now, but that means when we started up, there were no units that failed on the startup. So this is a pretty clean system right here. But if I came to a system and I had never been on it, I'm always checking the uptime. I'm always checking the kernel version and the version of the OS. Those are things I check, just like I showed you guys in this lab. But the other thing I do is I see how the system started. I start to dig in on what users are connected. Am I connected up to a trust authority so that we have what we call like a federated access so people can get in from outside? I start to check all these things. These are things that I do, and those are going to be specific to the environment you're in, right? So Let's look at this real quick then. I said you could do PSEF, that'll show you everything, but then you can carve it down, and the carving looks like this. So PSEF dropped everything up above here. Then we said awk print 1, which is just this first column right here. So all of this line right here, just that column, got printed out. So we captured all of this, and we threw everything over here to the right away. We only have this one column. That's what this awk does. Then we sort it so they're in order, alphabetical order, and then we do a unique with a count. And we see that the UID was just the list at the top. That was a header. That doesn't matter. Daemon, message, root, syslog, and systemd. So if somebody asked me, is this system really doing anything, or is it just sitting there operating as an operating system? I would tell you, this system's doing nothing. We see it sitting idle, and we see all these processes for it, but they're literally just the server running, and most of it's under root. Now, if there were other users on here and that kind of stuff, I could go see what those users are doing, and then I can also look at their usage and see what's happening. All right. So there's all these things that we can kind of start to figure out by these basic little commands. So we come over here and we look at what's exactly happening in every 1 second across the processor. We can see the actual command that's running, and we can actually see what the PID is, the process ID. And here's UID of 0 is root, right? So root has been running these things, and across the processor, excuse me, at exactly that second, there's basically nothing going on. If I rerun it, I'll get different output, but it's for that 1 second of time. That one, not even 1 second, that one little slice of time was anything going across the processor. And in this case, it was PIDstat, or it was a node command. It was like nothing going on. How much of the system cycles was it using here? And for the most part, the system's sitting completely idle. Because these right here, you might notice if you went back to our MPstat, these are the same types of things that are showing up here. You're just not getting the idle. You don't see the idle output here. You just see usage output, which is basically, again, nothing. This box is chilling. This box is not doing anything. If I did some of these same commands in my home lab, all kinds of things are happening on my server, so you're going to see more usage. The goal is to keep your server usage in a range that is acceptable. We have a thing called the usage, the utilization, the saturation, and the errors, and we might get into that a little bit. I guess I can pull it up. Hold on a second here. I'll pull it up. We do labs on Sundays, but that doesn't mean I can't go explain things. Let's go to our Linux Systems Administration. Pull this up for a second. Just for a little bit. Here is... Did I already pass it? Yeah. For all systems, we use the use methodology, which is the utilization, 0 to 100%. Saturation is as we start to wait in a queue, and then errors start to form as timeouts happen during a queue. So this is a thing to check, like as a quick check if there's problems on your servers. Utilization, are we hitting 100% utilization of CPU, memory, disk, or network? Those are the 4 big ones. What's then the saturation of that, meaning how many people are waiting in line, how many processes and things are waiting in line behind that, and then what are the errors around that? And these are the things that we use these tools to find out. Okay? So we use these simple tools to figure out, in this case, there's no full utilization of anything to 100%, meaning that our idle would be 0, right? And then there's no saturation, because with saturation we would start to see things queuing up and waiting to do things. We would see that with, like, with this, where you start to see things waiting here. You can also look in the VMstat. When these start to back up, that means that you've got saturation on the system, because you've got a lot of processes waiting for the processor. So these simple tools that look really easy to read start to become more and more useful to you. Now, as systems administrators and engineers, we look at these tools all the time to see right now what's going on with the system. but you still have to have monitoring that gives you a historical context to it. And what I mean by that is like this. Let's go look at, let's check Ranger out real quick. Oh, there's Ranger. And then let's go check our Prolog stuff. And here's my CPU. See, my CPU spikes every day. This is a 7-day window. And every day, some of my systems kind of spike on their CPU. They go pretty high. But why do they do that? Well, I happen to know that they're running an antivirus scan. And that antivirus scan causes them to have higher memory usage and higher CPU usage. So if I'm seeing high memory or CPU usage during those windows, now I have a historical context to know that what I'm seeing in my actual command output. So over here, I see a command, but there's no real context here besides I know that the system is or isn't being used. But then with a historical context like this is why we track data. Now I can make decisions around, well, I expected it to be a little high here, so I do expect some saturation at this time, especially if a bunch of users come in. Now, if you're doing your scan like this and it's going till 10 a.m., I might need to move this earlier in the night because they kick off at 3:14 a.m. every morning. There may be some smart things where, well, all users come in at 9 a.m. and this thing doesn't finish until 10 a.m., well, I need to move this back so it doesn't affect users. I may have to deconflict some things, but I can't tell this kind of detail about things. This is historical context versus this, which is simply what the system's seeing now. Does that kind of make sense? Yeah, I use ClamAV, Cheeto. Yeah, I actually have a lab, and the one lab on Clam Antivirus uses the same scanner that I wrote for my home lab. Yeah. If you didn't know that, it's the same exact scanner for ClamAV. So, and then we can do ioat. Ioat looks for two things: the devices and the CPU. So there's CPU usage and device usage, and it looks like the CPU is chilling and the devices are not even being written to. But up here, when it first kicked off, the CPU did show up, and all of the devices, they are not disks, they are devices. This one happens to be a disk here, but they are all the devices within the system that show up right here. And then you say, well, is any of these values, like the read-write, is that high or low? Well, high or low would be relative to what you expect, right? So you need to get some historical context to know if any of these are high. Are we hitting any, have we ever tested how fast our system actually can read and write? And I've got some labs where we do some benchmarking and we see how well our system works under a load, right? So these are things that, I'm throwing a lot of terms at you, right? But these are the kind of things that we need to check on. We need to check on how Ranger's doing. I gave him, his bowl was empty for water this morning. I gave him water, and he sat in there and drank for like 2 minutes straight. He was just like sitting there slapping the water with his tongue. It's kind of funny. But Ranger's a pretty good dog. All right, so then we do a little bit of networking. Look, we're almost out of time. We got 5 minutes left on this lab because I've been talking a lot. But then it says that we can look at, I'm going to shrink this down just a little bit. And then we can look at all of the interfaces on the system. So SAR -n dev 1.5, what does that do? It shows us RX and TX info for all interfaces. Now, RX is always in systems world receive, and TX is always send. It's always the send side of the link, and the RX is always the receive side of the link, always. So and that's across the rest of your career. I don't care if you're in networking. If you're heavily in networking, like I always have been, you'll do that a lot. You'll see RX and TX. Systems world, obviously, we see it because our systems are using the network at all times. That's why it's important to know your networking. No Linux box in the world exists just to exist as a Linux box. It exists to be part of a network and part of a system and all those type of things, right? So then we can look at the errors. So we see the transmit and the receive and all this kind of stuff, but now we can look at the errors on the line. So here's the passing. So hold on, we'll let it finish. Here's all the active and passive. This is like an aggregation of all the traffic that's good and all the traffic that's bad here. So active and passive, if there's anything being sent on the network, and then here's any retransmits and errors and those kind of things. All right, so We just do SAR-N TCP ETCP 1.5. That'll give you every 5 seconds all good and error traffic on the network interfaces, right? And that's an aggregation, as you can see there, for the system. All right. So, man, we really wrung everything we could out of that lab. I talked for an hour on just the first one. This is just the first lab. So like it says, it expires in 3 minutes. Hit check. Look at you learning Linux. You looked around the OS. We took a bunch of notes, told us about the system, told us where we were. So then our next one will be, you should be, well, I guess they don't need to be in. Oh, I like that. I like how everything moved in there. That's pretty cool. So our next lab, we'll back out of here. We'll go into the next lab, which will be specifically looking at kernel and packages, right? What's going on inside the system. So how do we get to that lab? Click on it. This is lab 2. We pull the lab 2 up right there, and then we say, all right, what's going on here? Same type of idea. Says you're a new systems administrator at your new system administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. Check your kernel package and info on the system. Echo the number of kernel versions that are stored in the system to root kernel. And find a specific version of the software that the security team has been asking about. Specifically SSH server and the client. Okay. Why might the security team ask you about that stuff? Anybody here ever worked on a security team or worked with a security team in like a networking or other context? They're always coming around, and if they've got tools that can scan things, they might not ask you a lot of questions because they know, but they probably sometimes need to know because a new vulnerability came out, or they have scanned and they found an error and they need you to go validate that that is what you're seeing on all the systems, because their next question is always going to be, well, can you then remove it? Can you update it? Let's get a plan together to do that, because that's literally all security thinks about, is how to make your life harder. No, I'm just kidding. Their goal is to make the system more secure, more locked down, right? So let's go look at this a little bit. Here's our solution. We can do a uname-a, and that will tell us everything about the system. It's Linux, it's Ubuntu, it's got this kernel. This is when that kernel was created, when it was originally compiled, and then the versions of the architecture for it, and then it's GNU Linux, right? Which there's that copy pasta everybody likes to paste, right? What you're calling Linux is actually GNU. People love doing that one. All right, so let's go look at where are the kernels that are on the system. We knew that we could do proc cmd line. We saw that earlier, but this kernel right here that's getting called, what can we tell about that? Well, we know it's in boot, so it's ls boot VM, and we see 3 different things that are in there. We see the one that was called at the kernel command line, then we see one that's just a generic name here, and we see one that's the vmlinux.old. Now, these are weird colors, but you're not always going to get colors inside of a system. So what you might do is you might look at those again and say ls-l, which will be a long listing, and maybe even ls-lh or ls-ls. But let's just do ls-l on boot VM like that. And now you're going to see that only one of these is a real file. This is the real file right here. The boot vmlinux 540.131 generic. These other 2 are soft links. They are soft links to that file. And you might say, Scott, how do you know they're soft link and not a hard link? Well, right here, this represents, this number right here is how many hard links point to a file. And this file right here only has 1 hard link pointing to it, but it has 2 soft links pointing to it, here and here. Now, we're not going to get too much into those right now. We do it, I think we have another lab where we deal with hard and soft links. Soft links can traverse file system partitions and boundaries. meaning you can have a soft link to like an NFS share that's not mounted yet, but a hard link, because it actually is an inode pointer to that system, must be within the same. So if I do a df-h on boot, right? If I want to hard link anything to that right there, it has to be in the same directory, right? And if you want to see that number change, if you're like, Scott, you might be lying to me, just cd to boot real quick, and then ls, and then do an ln without the -s, and just link your kernel, which is the generic kernel here, right? Boom. Paste it. And then link that to, test link or something like that. I don't know, just for fun. And now when you do an ls-l on your boot VM, right, you're going to see this weird thing where now there's a 2 there, because there's another hard link to that. You see how there's only 1 there, but now it's a 2? And it's because the other one that's pointing there is this little test link. So if I ls-l test link, that also has a 2, because that other memory pointer, this one right here that's pointing to the inode, is also pointing to the same location. They are the same exact file, but with just 2 inodes pointing to the file on the disk. When you delete something in Linux, all you've done in Linux when you delete something is you have reduced the number of hard links to that file to 0, according to the operating system. You have not touched the file off the disk. You have not overwritten the file on the disk. You have freed up that memory location for the OS to reuse, but until something overwrites that file, all you did was reduce the number of hard links to that file to 0. So there are tools that are out there. There are techniques to go and relink things back to that. And there are things that keep track of that. So if you accidentally delete something, you can put it back. But those things are unreliable at best. ls-i. Whoops. Yep, and that should be the same then as this guy. There you go. Right? Should be the same. Should be the same because they're pointing to the same place. So, if I deleted both of those, I'd break this system from reboot. But this system never reboots anyway, so it doesn't matter. All right, so we got asked yesterday. I did a poll, and people wanted the most basic Linux stuff we could do, so that's what we're doing. Right? We're doing like just as basic as it gets. We're doing our commands over here. I'm adding a little bit as we kind of go, and if you were to ask, if you were to say, I know Scott said something, but I don't remember what he said. Hard v soft link. Hard has to be within the same partition. Soft can be across partitions and will remain broken until a file system comes up. So you could put a soft link to like an NFS share, and until that NFS share comes up, it'll just be a broken link. But then when that NFS share gets attached to your system, provided it's the right path, that soft link will go right to it, and then people can use that without any problems or any of that kind of stuff. So that actually ends up being kind of a useful little a useful little trick sometimes for maybe if you know that the back end is going to change. You can use a soft link. You can change the back end to NFS without affecting anything that your users see. Because you got to remember, Linux boxes have users. Those users tend to be more power user-ish. They tend to be like your software engineers and like your people that understand systems. But that doesn't mean that it's not easier for us to just abstract things away from them. Let them see, slash data. And slash data can be a moving point underneath because maybe sometimes they're in prod, sometimes they're in dev, whatever. I don't know. I don't know what you're doing with your data. Maybe you're sometimes in dev, sometimes you're in QA or test. You typically wouldn't move a dev system up to prod. But my point is, you don't let them see that. You abstract that out. And soft links are a way to do that. All right. So we only had one kernel, so we're going to echo one into root kernel. We have to do that for the lab because that's how I have the lab move you forward. Like, you can't move forward until you have the right answers in that file. So there we go. Next, we're going to check how many packages are on the system. So let's run a dpackage-l, which will dump. You could do a dpackage-l. You can just do it by itself on your system, and it will give you all the packages that are on the system. But as you might think, I'm hitting spacebar to go page by page. That's a lot of information. So what I might do instead is say, well, approximately 721 packages are on here. There's 5. If you notice, there were like 5 headers. If you just want to see the head, you can see just the first 10 lines. And remember I said those first 5 are just kind of bullshit lines. They're like header lines. So there's that. And then like here's information about the system. And then you can say, well, I want to look for SSH because the security team came and asked about SSH because they think that there's a specific vulnerability in this. In libssh of 0.93 to Ubuntu 2.2, we got an alert from Qualys, or it's QUALYS, or Tenable Security, or we were looking on the NIST database and we found that there's a CVE score, or there's a CVE on there with a CVSS score of like 8. That's a pretty high score. We need to get that remediated within 30 days typically. And your organization will have different security postures for how often they do that. But now I can see the version of my client and the version of my SSH server, and then I can see about updating them and that kind of stuff. So the client is named the OpenSSH client right there. And there's our version. And then here's the server right here. Boom. And then you can go look for anything. You could say, hey, I've heard of this tool. I've heard of this tool that's pretty good called, I don't know, Calce. Calce is so fucking annoying. And there's no Calce on this box. So maybe security came through and said, hey, we need to make sure that that's not on there. Or maybe bzip shouldn't be on the system because we have gzip. And gzip is the better version. And it is a one that should be used. And bzip is maybe an older version that should no longer be used. So we could come in here and go, okay, now we can build a plan for removing bzip out of our system. We want to probably inform our users because some people probably have scripts and other things that use bzip. And let's just search for zip in general, because there may also be a gzip, bzip, and then an unzip. But we don't have the zip package. We have the unzip package, which darchives, but we don't have the zip package. Zip and bzip and gzip are all different. That's funny. This thing's trying to figure out what the hell I'm saying. Sometimes, if you guys ever see my closed captioning going crazy, do me a favor and clip it for me, because sometimes that thing just can't keep up with what we're talking about. So sometimes it's okay, but not when we start talking system stuff. So look at you learning Linux. You did kernel and packages. You did a lot of stuff there. If we clear this screen up, we do a history, there's a fair amount of things here that were kind of interesting. How do we see all packages? We use dpackage-l. Now, here's a question. Here's a question to think about as a systems administrator, systems engineer. Can there be packages on the system that were not put there by dpackage? Is that possible? Like if I had a cluster of servers and I looked at dpackage and here's all these operating system level packages, is it possible that like we compiled something from source? Is it possible that we installed something without using a package manager? Is that possible on Linux systems? I mean, I'm root. Don't I have literally every power on here that could happen? I could rip the guts out of the system and watch it crash. We can do whatever we want to this box. We're root. Do we have the ability to add packages that aren't shown in dpackage-l? Do users have that power? It's an interesting thing. Yeah, Jake Sec, thanks for coming by. Just finished technical training program at the new job, now going into my official role. First assignment has been a part of API security initiative at the company. Really excited to start gaining experience. Nice, Jake Sec. If I can take an aside real quick for API security, one of the things to know, you probably know this, Jake. Look, maybe I'm telling you something you know, but maybe one person out here hasn't heard of this. If you're doing API security, OWASP API top 10, And when you look at this, you find OWASP API security top 10. There's all these other things about it, but you want the actual OWASP site. And here are the most important, or the most things. Oh, sorry, Doc, I've been missing your stuff. Laptop freezes every 1 hour. Oh no, that's no good, Doc. Real quick though, did you guys know that these two right here, they account for like, I want to say like 40 and 45% between them. These ones are like 90%, I think, when you add them up together, of all of the vulnerabilities and APIs that are known are the top two. You can go read about them, but these are the top 10 OWASP for APIs. And again, these top two are by far the most common across the board, across the world. Did you guys know that? Like, you could go be a rock star in API security if you just go fix these two for people, because you would be literally fixing almost everything. It's ridiculous. But yeah, anyways, you probably already know that, JakeSec, but go spend some time with that for anybody else that wants to get into OWASP or sorry, API type security. And even if you're like, some of our guys are software engineers, like Robodom, who's one of our mods. He wants to be a front end developer. That's what he wants to do. He wants to build pages and do front end, interactions of systems and stuff. And that's what he does. Well, he got a Security Plus. Well, one, because we kind of forced him to do it, and two, no, I'm just kidding. But two, he wanted to better understand how security integrates with his job. Because guys, I'm telling you, there's no task you can do once you get like put in an IT role. You put a little IT hat on and you walk into the IT department. I don't care if you're walking to the help desk. I don't care if you're walking to the managers, the network operations or security operations. They got their little bullpens down there. I don't care if you're in security directly or systems engineering or software development. Every single effing one of you, your number one thing you need to think about is securing those systems, because you have to keep control of your systems. In all ways, because the data, right, losing customer data and losing the reputation of your organization, that crushes organizations more than the fines that happen. The fines that happen suck. You get fined for, from the state of Washington, or you get fined from the US, or GDPR gets you over in Europe. That sucks, but the fact that you're going to lose business forever for reputation's bad. Front-end development was much easier in the 90s. Yeah, for sure. Okay, so yeah, we did that lab. That lab was pretty straightforward, pretty simple. Just showed you some kernel stuff, but there's some stuff to absorb there. There's a lot of stuff to think about in the different tooling, because again, I'm just like, it's almost like I'm just picking up little tools out of a box, and I'm like, this is a hammer. You go like this with a hammer. And you're like, well, that's cool. But then I see you just like go over by a tree and start going like this with the hammer. It doesn't, like, you have to understand the application of the thing, right? Like, I can show you all these tools, but you have to spend time to kind of absorb and know when to use your tools, right? Systems engineers, right? I see myself up there going like this on one of my windows. All right. So let's look at disks. We'll do some disk stuff here. So this will be the next one, which is lab 3. Again, we got asked to do the most basic Linux administration, so that's what we're doing. I'm going to pin this lab on the Twitch side, and I'm going to say unpin after 40 minutes, and then I'll just put it over here on the YouTube side. Oh, Doc, yeah, don't be suicidal. That's not good. That's not good. All right. There's a Rick and Morty. I don't know how they got that Rick and Morty through, but all right, I won't talk about that. But if you guys like, wait a minute, timer must be between 30 seconds and 30 minutes. Oh wow, okay. Well, I guess we'll do 30 minutes over there. Is that good? All right, 30 minutes. Unpin after 30 minutes. All right, good. There we go. All right, so that's pinned on the Twitch side. You guys see it on the YouTube side. If you want to do the lab with me, here we go. I put it over here. Disk and mount information. You're a new system administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. That's pretty much true. We're going to check our physical disks, what's physically in that system. Even if they're virtual disks, it's still what that system knows, so we can call them physical disks. They could be virtual disks as well. We're going to echo the number of physical disks that we have into root disks, and then we're going to echo the number of partitions of that disk into root partition. So we're going to find out some information. We're going to report it to a file just so the lab can let us go forward. And the first thing that we're going to do, I'm a big fan of fdisk. Not everybody uses this tool, but I like fdisk. If you do fdisk-L by itself, it will dump a whole bunch of information to the screen. And that's good. There's a lot of information there. But then what we can do is the command that's there, and we'll add a grep on the end. So we'll capture everything that was coming out to standard output on the screen, and we're going to grep it, which again, GNU regular expression processor, and we're going to look for VD. I think that's what grep stands for. Anyways, here's the disk. The one disk that's in there is 20 gigs. And then that disk has been carved into 3 partitions, a /VDA1. So VDA means that it is the first disk. That A represents the first of the disks. The next disk would be VDB, VDC, and those would increment. And then the partitions, in this case, are 1, 14, and 15. Now, partitions are much more arbitrary, but in the older boot record type, you could have 4 primary partitions. So we could have 1, 2, 3, or 4, and then 4 could be used. 4 could be converted over, so you couldn't use the 4th one anymore, and you could make that into an extended one that could go all the way up to 63. Yeah, something like that, right? So the 14 and 15, these are fine, but these are extended partition numbers here, and this is a primary partition number. Doesn't matter. It's here nor there, and it doesn't really matter to most people. Most people are never going to get to that level of partitions to run out, but that is how you look at those. All right. So another way to look at these disks is we can do an ls block, and we can list the blocks, all the block devices. Remember I said these are block devices, but they're not disks. I said that earlier today. So those exist on your system, but they're not really doing anything. They're just kind of memory. They're memory locations that are being used as loop mount points. So it doesn't really matter. Here's our VDA disk, our first disk and only disk in this case. Then we got VDA1, VDA14, and VDA15. And the root of the file system is mounted on VDA1. And then the boot EFI is mounted off of VDA15. All right. That's how you kind of read those. Then we can do block ID. And block ID will show us about a bunch of stuff here. Dev VDA1, there's a label that's assigned to it. There's a UUID that's assigned to it. There's a part UUID that's assigned to it. And then there's one of the most important things to us, which is the type, which tells us it's an ext4 type file system. If we make file systems we make a partition, then we put a file system on it. We tend to do ext4 or XFS nowadays. This is an ext4. That is going to be determined then, or well, not determined. That's going to be useful later when we go to mount it. There are auto mount programs and mount helper programs that will mount the system as the type of file system that it should be. But really, if you know what you're doing with the system, you should explicitly say the type of mount that you have. Yeah, so the UUID and the part UUID, the part UUID is assigned to the system one time. The UUID comes from, forget where the UUID is generated, but part UUID is generated by the system one time later. There's I was just using these recently. I can show you where they map and all that stuff, but I forget. I know the part UUID is generated later, and the UUID is generated before the system even boots. So this is given to the system, right? UUID is generated and given to the system. Part UUID is generated within the system. So that, I guess that's an important thing to know. Real quick, we can go look at these. So I can cd to dev disk, dev. And then in here, if I look at the disk, let's go, so in here, cd dev, ls real quick. Here's all those disks, and here is VDA right here. So VDA is a disk, and you say, oh, that's weird. It's got these weird backgrounds. The colors aren't always there, but that's a block device, right? So these are different things that exist here and can be used within the system. But now the question is, let's go grab this real quick. VDA. Yeah, let's grab VDA1 and VDA2 here. So we're going to grab these for this. And then what I'm going to do is I'm going to show you how those all map. So we'll go to, actually, I think we do it later in the lab, but if we CD down into disk in here, right, so dev disk, we've got by label, by part UUID, by path, and by UUID. Those things are all going to map over here. So let's look at dev VDA1. Let's CD into by label, and then let's ls-l in here, and cloud img rootfs, you go up one directory to VDA1. So from here you go up one directory, dev VDA1 is the soft link of the cloud img rootfs right here. That is this guy right here. That's that mapping to VDA1. Then if we CD up one and go down into by UUID, and we do an ls-l, we'll see VDA1 is 666.195, 666.195, and then it ends with 48C8. There you go, boom, 48C8. Typically, you just gotta look at the first ones and the last ones. So, part UUID, same thing, up, down into part by part UUID, right? ls-l, and the VDA1 is 1B586E, 1B586E, right there. So that's all the mapping. Cygamma said, "Do you think WSL2 on Ubuntu is good enough to learn on?" Yeah, I think so. Like, when you're learning how like the systems work, the disk stuff, the processor stuff, a lot of the kernel stuff is going to be the same. You're going to get different output, but the commands are the same across all Linux. Networking's different, disk layout's a little different, but like these basic commands that I'm showing, they're the same across all systems. So you need to kind of know how these tools work, but you can learn that Cygamma on any Linux box. When you get a little later on though, when you get a little later on and you're like more into like doing your like you want to get like you're like, I want to get a Red Hat role at a government facility or at like a contractor to a government facility. That's when you're going to shift over and really focus. But I'd say 90% of your stuff, man. And I watch people, like I've helped people for years to get into Linux, but I'll watch people kind of get like paralyzed by like trying to figure out all this other stuff that doesn't matter, when really all that matters is you get your hands on this stuff and start doing it. You start doing labs. They don't have to be my labs. There's all kinds of labs on Killer Code. You're literally just doing something. You're getting your hands on these systems, because we were talking about this last night. Somebody was talking about they wanted to get into I think I forget exactly what the context was, but it was, we were doing something with Kubernetes and they were asking, well, they were asking, should they just read man pages? And I'm like, man, I don't know, man. That's like just going and reading RFCs for like networking. Like you can learn networking that way, but you're probably going to take a lot of naps too, because that shit's going to put you to sleep. What would be better in my mind is come and just do stuff like this. And this is like you're following me around the gym. You don't know why I'm putting weight on the bench. You don't understand that you're working chest and shoulders and you don't understand any of that. You're just watching me do the stuff. You're just watching the output. But over time, you're like, oh, no, I do remember how to go get disk information. We've been doing that in the labs. And like, oh, I do kind of remember. I can PS. PS was my buddy. PS with EF can start to show me how to see all the processes. I can dig in. I don't remember exactly how to see what the open port was, but, I can go read some, like, these are the kind of things that I think are valuable to you guys, is like getting into systems engineering. Literally getting your hands on systems and understanding some of these things. They seem so basic, but they are really like really valuable, I think. So I don't know. I just maybe it's just because I forgot how I got here, but I know I learned all my stuff in the wild. I learned all my stuff by figuring it out and going and doing it. I told you guys I had one class in college on Linux. Most of my stuff I just kind of learned by being the guy that would kind of jump in and do it. And this is a way to kind of ease yourself into doing this. So we're going to check our file system and mount points. We're going to echo the file system type into root partition rootfs. We know the file system type. We just saw it a little while ago. It was ext4, right? Yep, boom. Echo the name of the file that defines all the mount points into root mount info. Well, the file that defines all mount points is etcfs tab, right? Let's go check that out. So we're going to do a mount, and we're going to look for VDA. Mount will show you, mount does this interesting thing. Hold on. Mount does this interesting thing. Mount will dump all the mount points on your system. It reads etcmtab, so you could cat etcmtab, which is your mount tab, but you should not change this file etcmtab you shouldn't change this. This is just a visual of like what's going on in the system. Everything is being read from proc mounts, I believe. Yeah, proc mounts is being read, and so don't muck around with things directly. Use the tools. That's going to be my advice. That's also the operating system. You'll get all kinds of warnings from people if you go read about it, and if you go read like the published stuff. Don't go modifying those directly. We'll use mount, and we'll grep for VDA. So we're just reading data right now. And we see VDA1 is off of /, so it's the root of the file system. It's ext4, it's read-write, and it's relatime. All right, so we see that. VDA15 is our boot EFI. It's got a whole bunch of other options in there. We don't really care about the options right now. So we're going to do a block ID on just devsd or devvda1, and we're going to see that he is ext4. We knew that from right there, but that's fine. We're going to throw that into rootfs type. So now we've got ext4 in that file system file. Again, this is just so the lab knows to take us forward. We didn't do that for any other reason. And then we're going to go cat etcfs tab. And etcfs tab is going to show us that root is mounted by using a label cloud img rootfs. We know that cloud img rootfs maps to devvda1 from this right over here. Also, we know that from looking at the file system. We now know that from looking in etcfs tab. That's how it was mounted. And we see that it's mounted right there. So everything points, it shoots and ladders. There's nothing in here that's like me casting a spell and then all of our stuff works. Every little thing in there is pointing to something else. And you might say, well, what if cloud img rootfs was wrong? There was like a 1 on the end of it. No, this shit would break. This server wouldn't come up because the label wouldn't match where it's trying to mount and it wouldn't work. So it's very precise. It's very accurate. And all the things point to other things. All right. Then I give, but the mapping is strange, so we can demystify it. This was that same thing that I showed you guys earlier, and you can demystify all of them at once by just going and running this command here, which goes and it just looks through all of them and says, well, cloud img rootfs maps to VDA1. This UUID, part UUID maps to 1. This PCI path maps to it. You don't really mount by PCI path, but that is the PCI path to our VDA1 disk, right? You don't typically use PCI path though. All right. And then we echo etcfs tab into root mount info, and then that'll tell us that that's done. So now we've checked. If we do a history, we've looked at our system, we've looked at disks and different information. You will get different values if you're using different servers. So like if I'm just on my werewolf box and I do a df-h, there's some mount. We're going to see that here in a second. ls block and block ID is going to show different things than you see here, but the command was the same thing. And look, oh man, look, I got a ROM. I got a SR0. That's like a disk drive, right? I don't even know how I have that as a virtual machine. Then I have XVDA, which is my virtual disk 1. And then in there I have XVDA 1 and 2. 2 has some kind of logical volume management applied to it, and that disk has RL root and RL swap applied to it. Now, in this lab, we don't do logical volume management, but I'll show it to you real quick. You got a PVS, VGS, and an LVS. This is the shortest way to see it. There's longer ways, but in PVS, I see that XVDA2 was given to the logical volume management, which makes sense because I see 2 logical volume management volume groups hanging off of it. Here is the volume group called RL, and RL is all 49 gigs of that. So that whole thing was 49 gigs, so we've got all that. And then that has been carved into 2 different logical volumes. The root, which is here, which is 44 gigs. Yep. And then the swap, which is 5 gigs, which is right there. Boom. There we go. All right. So now we've done these things here. Let's go look at the disk size and usage. Let's look at the partition for root and put in a file called root size. Then we'll place a single file for 3 gigs in that location. And then we'll make 10,000 files and look at those as well. So we're just going to make a bunch of files on the system. So we do a df-h. H is human readable. You can do df by itself, but I would never in a million years look at that. That looks like crap. df-h will show us that the root of the file system, right here, we have 15 gigs available. We have 4.6 gigs used of a 20 gig disk. So we got about 15 gigs available. We're at about 24% usage. So we can remember that. We can also say df-h on just that, and we will just see that one output. Okay. So now we can look at that for just the size. And if we wanted to, we can look at that output right there and see that, yeah, 20 gig is the size of that disk right there. So all we did was df-h. We looked for size. We got rid of the size, which is the header. And then we put the second value, which is this value right here. 20 gigs. Boom. Easy enough, right? I said this command just cuts the unnecessary information out. That's fine. Check the output by removing the root size. That's what we did, so we could see it. And then now I said, let's make a giant file filled with zeros and then check the space available. So if we did a df-h on root, we've got 15 gigs available. If we make a file that is 3 gigs, so that's 3,000 1 meg blocks, which is a gig, we have 3.1 gigs approximately written in, and we wrote at 1.1 gigs a second. That's gigabytes per second. So it took almost 3 seconds to work, right? So that's a data point. If we wanted to test the speed of our system writing zeros in, that's it right there. If we needed to write to some far file system, this is an excellent command for it. It's a disk duplicator. We're grabbing just a bunch of zeros off the processor and writing them out to a file that has a block size of 1024, which is 1 meg. 1024K is 1 meg, and a count of 3,000, that's 3 gigs total. Boom. So now we go and look again, and we only have 12 gigs available because we used some of the 15 gigs that we had. 3 of them specifically, right? And then we see that big file there. All right. So then we go and we just make a bunch of files. So we could do a df-i on root and see our inodes. Inodes are memory pointer locations. And we have, 2 and some change million free of those. But let's use 10,000 of them up. Let's make 10,000 files real quick. And we'll look, we had 2.4 million and some change. We ran that, and now we have 2.45 instead of 2.46 right here. So we used, right here, we had 65,000, now we have 55,000, right? So we used 10,000 pointers for file. So if we ls in root real quick, we'll see 10,000 files in there, right? And so df-i on root shows us how many inodes are free. You will probably never in your, if you have a 20, 30 year career in Linux, which I think you still could if you started now, right? If you're an engineer that wants to get into this, I think Linux and Unix style systems will be around. I think we'll still be kicking as administrators. You will probably never run out of this on an operating system, but you will run out of inodes on your SAN storage, because SAN storage is these massive spaces, and people will do processing up to them in high performance compute and different stuff like that, and they will use really small files, they will generate really small files, and they will use up the inode sometimes. I've seen that at least 2 times in GPFS, and I've seen it approach it a 3rd time. So we caught it the 3rd time because we put better monitoring in place. But you should track these on your big SAN storage devices and on your high performance compute like cluster storage. You should track these and watch them to approach 0 so that you can up the inodes. And different file systems will allow you to up the inodes in different ways. You can do that. If you need to do that, it's a tune2fs command. You need to take the file system offline to do it. So you'll typically have to boot into another like either boot down into a rescue mode, or you're going to have to boot into like another system, and then you would use tune2fs and then we should be able to read the man here. So man tune to FS. This will tune the file system for the things. But again, you can't do this live. This box has to go down so that root is unmounted for us to do this to it. But yeah, you can tune to FS and then look for inode. And then in here would be change the size, the inode size used by this file system. This requires rewriting the inode table. So it requires that the file system is checked for consistency first so you have to do an E2 FSK to make sure the file system's healthy. And then it will take a while, especially on big file systems, to change that. But then you can go in there and do that. Okay. You will sometimes have to fix file systems and do different stuff like that, and Tune2FS is a good tool for it. I can't really show you this in these labs because we can't take... Well, I can show you this in the home lab environment when people get in for like the Prolog group, because you'll have werewolf nodes that will have their own stuff, and we can take them off and we can tune the file system and put it back up. So I'm going to put that in my notes to say... So in my notes... write out how to use Tune2FS in the system admin 16-week course. That's coming up here soon too. If you guys haven't heard about it, we've got I haven't really been hammering this, but we've got a Discord, right? And this Discord exists out in the world for you guys. There's a beginner section to like how beginners start, and then up here we've got a whole bunch of events coming up. And there's an event later today, actually that's in a few hours, where Salty Catfish comes and talks about doing coding and working on a team. He's been a senior software guy for like the whole time I've known him, and he's been doing a software engineering role for 15 years or so. We also have a pre-sales engineering talk where one of the guys out in the industry, he works for Red Hat, is going to come and talk to you guys about like being an engineer and then getting into pre-sales engineering and why you might want to do that instead of being an engineer. He actually runs an academy that trains people on that. I don't know how much he's going to talk about that, but he's going to tell you guys about those different roles. And I think his talks are excellent. So there's that. And then I'm doing, in the next few weeks, we're going to start a 16-week Linux systems administration course. So pre-sales, so pre-sales engineering it's kind of like this, right? Like you're a big company, like we were AAA. I used to, be the platform engineer, and I would work with Red Hat all the time. And Red Hat would come in and they'd be like, all right, you guys are running Red Hat pretty much everywhere, and you've got satellite, but have you guys thought about OpenShift? And we're like, we thought about OpenShift. And they're like, all right, hold on. We're going to bring in, so you've got kind of like a sales guy that goes out and tries to do that, and they're typically like your systems, what would you call them? They're kind of like your service rep. And they'll bring in a pre-sales engineer, and the pre-sales engineer will do like this whole big plan. They'll look at your network, they'll look at your systems and go, okay, if we were to try to move, you guys have a goal of maybe moving 10% of your systems from physical and virtual down to this like maybe Kubernetes style. So we'll set up an OpenShift that can handle 10% of that, and it would look like this. So they set up a plan, and then that kind of goes into like sales to your company now buys that for a few million or whatever. But they set that all up. They pat themselves on the back, you shake their hand and say thank you, and then they go on to the next project. They only design and build things, they never maintain them. Whereas most of us in engineering, we have to maintain things for long times, we have to end of life, we have to, cry as our servers go down for the last time, and we're like, that mother effer gave me so many problems late at night, I'm decommissioning him for the last time, and you're like standing over its grave and stuff. That's what engineering is. Pre-sales engineering, they just come out and design stuff and build it and leave. Go on to the next project. They're always working with new stuff. They're always so a lot of people like pre-sales engineering that maybe don't want to be some, old angry engineer that's been running systems forever, if that kind of makes sense. I would also, I hate to say this like this because this is going to sound bad, but this is almost kind of like a young man's game, if you will, because you probably have to do a lot of travel. You're working with a lot of different clients. I'm not saying you couldn't do this in your older, but I'm saying like kind of like, and you can make good money at this too, because you make money here a lot like salespeople do. Whereas engineering, we make good money, but we just make engineering money, right? So hopefully that's clear as mud. And when I say something's a young man's game, what I mean by that is a lot of the older guys are like, I don't want to go do that anymore. I don't want to go do the rat race and run around and be on the red line, the red line, or not red line, red eye flight out to wherever and back the next day. Some of us don't like doing that anymore, right? We got families and stuff. It's already weird enough for me. I'm going out to Austin. I'm flying out tomorrow, and I'm going to be out there all week. I don't do that anymore. I can do everything I need to from home, right? Except for this. This is just a setup of a physical system, so I need to actually be out there for it. All right. Anyways, look at you learning Linux. You used disk. You looked at the disk space and usage. You built a bunch of files. You tore them down. You did all the kind of things that you needed, and that lab kind of showed you how to do it. All right. I'm gonna take a quick break. Did I turn myself off? Good. Let's go to Ranger Cam. There's Ranger. Look at him. And we'll put a little hourglass up. Hopefully that answered the question about what pre-sales engineering is. We'll say quick break, then more labs. Take notes. All right. All right. I will be back shortly. You guys manage yourselves. Doc, hopefully you're doing all right over on the right side, on the YouTube side of things. We'll get back to it here shortly. All right, take a break, walk around, smoke them if you got them. I don't do none of that stuff, but all right, I'll be back. All right. I'm back, but we're still on break. All right, all right. Catching up on stuff. Looks like you guys are doing all right. Ranger's doing okay. We'll leave that up. Next one's going to be IP stuff. Let me show you guys this while we're talking here. We're still on break, but hang out a little bit. We have the here. We have a Discord. You guys can hang out down there if you want. Man, we're almost 2,500 people, which is pretty wild. We were only hitting 1,000 a few months ago. We had been like pushing. It took us like almost 5 years to get to 1,000, and then we jumped up really quick because of YouTube, actually. Oh yeah, Chillin' Spree. So I use a few different note-taking apps. This is Logsec, LOGSEQ. So it's LOGSEQ. I also use Notepad++ sometimes. So there's just questions here that we were doing when we were doing the Socratic method. This was the Socratic Linux, and we could just go through and ask ourselves questions and do those, you know, type of things as well. And then I do use OneNote. I use OneNote for some of my doctorate work and keeping track of things. So I have a few different note programs. I'm liking the LogSec. I think it is good. You can also draw things in here. So you can just go right to whiteboard, and I could just say like, oh yeah, we're doing this disk information. I could just start drawing the disks up here for you guys. I got my little pen and my stylus, and I could just start. The only problem is, this is the only problem with it, is the way my stylus is set up. I would prefer to draw over here, so I'd have to probably switch the screen around if I were to be more, if I was doing more drawing today, and then I could be like, all right, here is your, you know, here's your disk maybe, and then here's your disk carved up into like, you know, partitions or something, and I could start showing that or whatever. Org mode. I haven't tried org mode. What is that? Hold on. Back to my journal here. What is that? We're still on break, so you guys can do whatever you want. I have not seen this. It is marked down, which is nice. You can drop in code, end code. Yeah, I mean, yeah. Looks interesting. Where's their GitHub? Oh wow. Oh, they're still working on it. That's good. It's good to see that they're still working on it. Emacs extension. Yeah, you gotta learn a whole bunch more shortcuts. Yeah. When I'm down in systems world, I will let my screen and my tmux just take notes directly into a log file for me. So I have that. Screen and tmux, TMUX. That thing is so terrible sometimes. Like it, I mean, I guess that's true of most things. It's not going to be able to tell what the engineering type stuff is. But anyways, yeah, names and stuff like that. But all right. But no, I haven't messed with that at all. It looks interesting. But I mostly do. Yeah, I mostly use VI if I'm down in terminal, like, because I'll be down like deep in terminals. And then since I'm typically using PuTTY or some type of other terminal, I can just grab blocks of code and throw them in my notepad. So I'll use Notepad++ for like pulling things out that are kind of critical to me for later, and then I'll use this to etch things down into like my final deployment or my final whatever product that I'm doing. And that's, look, my workflow looks like madness. I try to tell you guys, like, if you watched me all day, you'd be like, I don't know how this guy gets shit done, but it's like a workflow that works for me, you know. So all right, we're gonna keep going through the labs, but we'll do, let's do one more lab, and then we'll go do some Socratic stuff. We'll ask ourselves some questions, and we'll figure some stuff out as we go. So the next lab's going to be the IP info type stuff, like looking at the system and seeing how the system works. So let me link this for you guys over here. Over there, you guys go on the YouTube side, and I'll pin this over on the Twitch side. So there you go on the Twitch side, and I'll make that 30 minutes. All right, so that's pinned. If anybody wants to follow along with me, you guys can, right? You're free to do that. And let's go ahead and do this lab. And as we do, we'll kind of think through, you know, I'm adding stuff over here on the right and kind of like my own notes as we go, like questions that come up, things that I'm trying to think about, or And what I'm doing is I'm showing you guys like what I think you should take as notes. I wrote the labs, you know, I know this stuff. But that being said, it's still valuable for me to practice this stuff. Like I try to tell you guys, like a lot of this stuff, you got to kind of keep yourself like fresh on it and kind of know how it works. So, all right, you're a new systems administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. Now you might say, Scott, that sounds like the same thing for the last 3. Yeah, that's what we've been doing. This whole time we've just been looking at servers and like very basic starting at the beginning. We're going to check all the network information we can figure out. We're going to pull the name of our network interface and put that in a file called root interface. We're going to put the IP address of our network interface into a file called root primary IP. And then we're going to write out the default route to a file called root default. So we're going to figure out everything we can about this system right here. And let's do that real quick. So the question here is, what do we want to know about a system? We want to know its interfaces. Can we see its interfaces? What are the IP addresses? And what are the subnet masks? So subnet masks, right? What are those? Can I pull all of this information about a system? Can I know the routes of how this system is going to send data in and out? And then we want to know what ports are we listening on, and that is commonly called open ports. So people might ask you, your security team might say, hey, what open ports do you have on that server? So let's see if we can figure out these things about the system. Can we figure out what interfaces are there? IP adder. Now you can add a -br in here. I like this. And it'll just give a brief about the interfaces. But right here you can also do just IP adder and it'll give you a bunch of information. But real quick, I see that I have 3 interfaces. I have 1 down, 1 unknown, and 1 up. There we go. So what are my interfaces? If I were looking at this system, I would say there's a loopback. LO, always in networking, defines the loopback interface. There's an ENP1S0. That LO should be lowercase, right? Because we're doing Linux and case matters. And then Docker 0. That's the other one. So those are our interfaces. Do we know their IP addresses? Yes. And do we also see their subnet masks? Yes. We won't write them all out, but yes, yes. And the loopback interface gives us 127.0.0.1, which is the default home of any system. Some of you guys have probably seen the little nerd shirts that they say there's no place with like 127.0.0.1. That loopback interface exists on every TCP IP connected device in the world. I don't care if it's a router, I don't care if it's a gateway or a firewall or a Linux box, whatever it is, its loopback has its 127.0.0.1 interface for all TCP, right? All TCP IP networks. There's also one that is a common address this is also your loopback address for your IPv6. So this is the IPv4 loopback and this is the IPv6. So I might ask you, are any of these interfaces, so under interfaces, are any of these running IPv6? And the answer is yes, only the loopback. Only the loopback interface is running IPv6. Not this one, because there's only an IPv4 address, and not this one, there's only an IPv4 address as well. So, we know the subnet masks. We might ask, what are the subnet masks of the interfaces, right? So we might ask that. And for loopback, what does 8 map to? Does anybody know what 8 looks like if you're actually putting it in a system? So you've got a /8, that's a CIDR notation. But what's the actual IP address? And some of you may know or may not know, I've been teaching for 16 years as a college professor on networking. Networking and computer sciencey type stuff. And security and all that. So what is this? This is 255.0.0.0. That's the subnet mask for that one with a /8. How about the ENP S0? By the way, Hajime no Uni, I don't, whatever that is, I didn't see it. Can you put, if you put spaces, or maybe if you say dot, I know it sucks, but that's the only way it'll come through. It came through as asterisks for me. That's like a weird thing on the Twitch side. Was it 255.0.0.0? Good. How about this next one? This next one is a /24. So what does a /24 look like? So this one, right? And I'm sure Hajime will know this. So 255.255.255.255.0. And how do I know that? Because it's a /24. Perfect. Perfect. And then this one is a /16. What does that one look like? Docker. Oops. God damn it. Docker 0 is going to be perfect. 255. He got it right. 255.0.0. That's exactly what it is. And if you say, can you break that out a little bit? We could. I have a set of, we're not going to do it right now, but if you guys ever need more help with that, let me know down in the Discord, and I will show you and I will walk you through this, as I've helped you guys do before over the years. This is the way that I show subnetting. I've been using this for years, and this is the way that I break it out and can show you all the different pieces. Now, as somebody might point out, well, IPv4 is going away. Yeah, but I've been hearing that since 2006, so IPv4 is still kicking. So it's still the standard in Kubernetes, so I know it's going to be around a while. All right, anyways, there's that. If you guys need that is up in our networking section, but if you need like practice ones of those, just let me know and I'll make them for you. All right, so look at all this stuff we found out. We didn't even do anything from the lab yet, really. We did our IP adder, that's it. So we can go, what's the name of our primary interface? There we go. We carved it down with this command. I'll let you go take that command apart if you want. And then we can go throw that in the root interface, and that'll let the lab move forward. And I said there's other ways to do this, but that'll do it in one command. That's fine. And then I said, what is the IP of your primary interface? Right? There it is. We saw that earlier already, so we've already gathered that. And then we can throw that in a file called root primary IP. And then now we can go look at the root type stuff. Hajime no Uni said, do you think that these v6 CVEs will slow people down adopting v6 as slow as that's been? Hajime, I doubt it. I mean, you're always going to find vulnerabilities and things, and then people are going to patch them out. IPv6 is better positioned for that anyways, because there's so much modularity in the header. In one of our other talks, when we talk about like the networking primer, I show you guys an IPv6 header, and there's all this modularity, things you can put in and pull out. And because of that, things can get updated when vulnerabilities are found. So I don't think that's going to slow it down much. I think people that are seriously implementing it are going to keep doing it. IPv6 just got hacked, so IPv4 is here to say, yeah, Netwit, I think that's what Hajime was talking about over on the Twitch side of things was, yeah, so IPv6 they've found vulnerabilities, but it's a vehicle that is much easier to work through. By the way, I've shown you guys this before, but I'm going to pull this up. There is a really good IPv6 certification out there. It's the only one I've ever heard of. One of our guys is always telling us about it. Look at the things that they'll teach you about IPv6 for free. There's this company called Hurricane Electric Internet Service. It's interesting because I've never heard of them before he mentioned it. And then you go look at them and you're like, wait, they run like internet all over the world. They are a huge company, this Hurricane Electric. But they've got a free IPv6 certification. You go, you register for it, it sets you up, I think it's a few hours. They used to send you a shirt that said that you had been through their class. But look at what they teach you about. You can learn about connectivity of systems, that's huge, that's valuable. And then they teach you about the concepts of like IPv6 from like how the links work. Yeah, this is probably one of the best things. And I've shown this a few times over the years because Inspector would always bring it up, Inspector Diameter. And he had taken it. And I want to say like 2 or 3 of our engineers went and took it and they liked it. They thought it was a really good resource. So, yeah, if you guys need it, it's right here. I'll link it to you guys because I know there's at least one person on YouTube that wants it or thinks it's good and at least one person over on Twitch. So there you go. Yeah, and look, free 99 is like the best price ever, right? Like free is a good price for most people, especially if it's still good, right? If it's not some garbage stuff. So yeah, so we've got that. We've done all these things. What does it else say to do in lab? Let's do an IP route. Let's look at our system. I'm gonna make this a little smaller so it fits better. I'm always changing the size so things fit better. But IP route shows us that default is gonna go through ENP1S0. So if it doesn't know where to send something, it's gonna use this. If it does know where to send it, so if it's a 172.17.00/16, it'll go out 172.17.0, which is the Docker interface. And then 172.30.1.0/24, it'll go out the ENP1S0 interface. So if we were to draw this out, right? If we were to try to figure out like how this routing table works, right? This is how this works. Let's go look at like a little whiteboard. I told you guys that I don't like doing the whiteboard because I gotta pull this over, but I should be able to do this. It's because my pen, it'll have my hand off the right side of my I got a little drawing pad here. So let's pull this up real quick. Hold on. Let's do draw. And hold on, I gotta grab, oh, that's the default. Okay. So the network for, if we have a 172.17.0.0, and then he's a /16. What does that mean, right? Well, there's 32 bits across this address. So if you have a /16 and each of these are an 8-bit octet, what you're really saying is if it maps right here, 172.16, if it matches this 172.17, it's gonna go out. In this case, that's the Docker. 0, right? Docker. It's like the worst K ever, but Docker 0. If it's a 172.30. Well, that's in the way now. Hold on, where's my eraser at? So that cuts there. But if it's a 172.30.1.0/24, right? And that's mapped perfectly here at the /24 bit. So if something is 172.30.1, that's going to go out ENP1S0 or whatever that is, right? It's going to go out that interface. If you don't meet either of those rules, then the default bucket at the end, so there's a default bucket, let's say, if you want to think of it like that, is to go out ENP1S0 to 172.30.0.1, which is the gateway over here. That is the gateway. 172.30.1.1 is what we call the default gateway. The other terms for that are gateway of last resort. So we sometimes call those gateways of last resort. That tends to be like a networking concept, though. If you don't know, the routing of a Linux kernel and the routing of a Cisco device are very similar. If you get to the end of the routing table and you do not know what to do with the packet, you don't have a default gateway or gateway of last resort set. Does anybody here know what a router does? Drops it on the floor. Doesn't give a shit. It's like playing hot potato. If it doesn't know what to do with it, it goes, ah, and then it just drops it on the floor. That's the best description. I mean, we don't know where bits go. They might go to bit heaven. They might go to the atmosphere. We don't know where bits go when they die. But we know that they don't get sent anywhere if they don't have a default gateway. So, all right. They go to bit. Yeah, they go to bit purgatory or bit not heaven. Yeah, okay. So my point in showing you guys that was you can really dig in with networking. But as with all things, right? I tell you guys this example all the time. And some of you are like, oh, God, Scott's talking about his fucking truck again. If I gave you the keys to my truck and said, go drive somewhere, and you got in my truck and you started it, and it started fine, you would probably just drive off, right? That's what everybody would do. But if you got in the truck and it went like it did Tuesday morning last week, and you found out that that thing likes to eat effing batteries, my truck, man, it's 6 years old next month. I've owned that truck. I only have 57,000 miles. I barely drive it. It's on its 5th or 6th battery now. It's ridiculous. That thing just chews on batteries. But anyways, where I'm going with that is you don't troubleshoot things that are working. But if something's broken, you need to know how to get in there. Name a car for an... Yeah, what I need you guys to do, or what you need to do is you don't have to dig in, and if everything's working and the system comes up and it's on the network and it's fine, it's good. So, yeah. Run-a-mucker 2001 Dakota, yeah. Yeah. I bought my truck, I got a 2019 Chevy Colorado that I got in 2018. So it'll be in a month, I think on the 5th of next month, it'll be 6 years old for me. I tell everybody, because they're always trying to get me to sell it back to the dealership now. And I'm like, look, I've owned this truck since I paid it off like a couple years after I bought it. I'm going to drive that truck till the wheels fall off it, but it's only got 57,000 miles. So that's probably quite a ways away. Yeah, because I don't really have to drive much anymore. And even you might say, well, what about before COVID? Do you guys know how close I lived to work? So AAA in Phoenix, I lived up in Glendale. I lived about 1.5 miles from work. So I did not drive much. Like I left home, I had to cross one major street called Bell Road, and that was it. And then AAA was like right there. So you might say, well, Scott, you just doxed yourself. Somebody could find where you live within 1 mile. Yeah, I've moved 1 mile further away now. So no, you should still be able to figure out generally where I am. But that's not that big of a deal. Okay, so what port? So now we get into routes. The next thing is we do IP route, and I say, well, there's routes, and we have two routes, right? And then we have one default route, or what could be like a gateway of last resort, and that one is 172.30.1.1. That's .1.1. That's how we send things, and it's off the interface ENP1S0. Right? So like if you were just figuring this out for yourself and like putting this into notes, that's why I tell you guys to take notes, because notes are valuable for you to come back later and go, what the heck was he talking about? And your notes are going to be different than my notes. In fact, a lot of times I don't even show you guys notes like this. I'm just showing you notes like this because if you were doing the labs with me, you could go, oh shit, yeah, that was useful. That is something I would want to know or whatever. Wadia Soft, thanks for the subscription. Keeps me motivated, keeps you from having to watch ads, so that's always super useful. What did I miss? 2001 Caddy Escalade. There's 250,000 miles on it. Nice. Yeah, Hajime, one of the things I tell people about owning a truck. I've owned a truck in some capacity since 1999. I've owned a truck sometime in some capacity since then, right? And I tell people all the time, if you don't want to feel lonely, like if you want friends and family to call you, own a truck, man, because you'll get called every Friday. Somebody's going to call you up, hey, man, got that truck? Want to come help me move? And I've literally helped hundreds of people move, and people will be like, hundreds? I lived in the barracks in the Army for 4 years when I was in. I never lived off post. So we would play, this is the worst game, but you'd have to move all your shit around in the barracks. That was the stupidest thing. So sometimes people would move or they'd go to a different, whatever. So, yeah. So, but yeah, I mean, like I tell people, there's tricks to not being lonely. Own a truck. People will call you. You don't believe me? Go buy a truck. Go buy an old truck. People will call you. People you didn't even know want to call you will call you. So, yeah. Hopefully your stuff lasts. Yeah, WRX. That's a WRX. That's Subaru, right? That's or am I thinking about something else? All right. So we look at our route. We can print that in and throw that into default route, and then we can ping things. So the ultimate test of things is, are we able to actually hit them? And ping is an echo request and an echo reply over ICMP, which is at layer 3. And ping is just the packet internetworking groper. So congratulations, now you know what that means. GRO, it says grouper. Groper. It's like you're groping something. Groping. Yeah, it's the more inappropriate sounding word. Yeah, it's a packet internetworking groper. Uses ICMP to echo request and echo reply. Yeah, nice. Nice, Wadia. Is that all-wheel drive? Those are pretty impressive little vehicles. I just got my truck and then the wife's car, and we thought about getting a van, having a big old, not a big old, but like a minivan. They say minivan. Yeah, man, when I had a kid, and then we got a grandkid, and the grandkid is turning 3, so like when the family comes down, everybody doesn't fit in my truck, even though it's pretty good size. I mean, it's good enough size truck, but like we want like a little more size for the grandbaby in the back and stuff, so we could just have a van, and that would be kind of good. I think we were looking at like a Toyota Sienna. I don't know, maybe, who knows. All-wheel drive, 6-speed manual. Yeah, nice. Just upgrade to the. Yeah, we've thought about it, Cuddlingus. Yeah, the little Siennas look nice. The wife puts a lot of miles on her car. She's got a little Honda Civic, but it's not that old. I mean, I think it's like 8 years old now, but she puts a lot of miles on it. And I told her, and the good thing is our vehicles are paid off, right? Like you don't want to get on a. I tell people, don't stay on that treadmill, man. Don't be always paying for stuff. So we haven't paid on vehicles for like at least 5 years now. So yeah, we haven't paid on vehicles for at least 5 years, right? Because it just paid off. Yeah, her car just keeps going. Only problem we had with that was one time she got the oil change and they didn't put the like the oil, not the oil pan, but there's like a cover, and then that thing was always just like flapping and hitting the highway and stuff and causing her problems. So, all right, we're gonna check the open port. So the last thing we wanted to do, there were 2 routes. Let me pull up these routes. So if you're going out here, you go to Docker 0. And then if you're going out here, you go to ENP1S0, like I mentioned. So that's the local network. This is a very small local network. This is only 254 possible hosts, right? Because you take 2 away. The very first one, the 172.30.1.0, is the network. And the last one, which is the 172.30.1.255, is the broadcast, right? So those 2 can't be used for hosts. So you got 254 total. This one is 65.534 because you can't use the first one and the last one. But that one can have 65.534 hosts. By the way, if you say, Scott, I can't remember that, then what you could do is you can come over here and say, well, there's 16. So it's 2 carroted to the 16. And there you go. And then you say, well, aha, but you're wrong. There's 2 missing. Well, the first one is the network. 172.17.00 is the network. That's the first one. And with all of them turned on, you'll have 172.17.255.255, and that will be the broadcast for that network. Now, that's a huge network. In practicality, we would carve that up into subnets, but since Docker is internal for just your machine, we just got this huge wide open area where we could just put machines out on there without confliction of resources or whatever. They go to Connecticut. All right. So, yeah, so that's look, that's the kind of things that we might want to know. So then we get here and we want to see, how is our system listening? So Mangler, yes, you do lose one for the gateway, but the gateway is still a host on the network. So you do lose that one. Useful, so useful would be 253, sure. But you do lose one because it has to be a gateway. The gateway is a host, though. So technically, he's still a host, yeah. Yeah. So Mangler, yeah, that's true. And then there's 2 other ones that get stolen if you do AWS. One is for their internal DNS interface, which will always be there. And one is experimental or expansion later. So I've seen critical infrastructure protected by firewall rules that using /16. That's brutal. That's brutal. Can I run Windows 10 in Docker and Ubuntu? Saber, I don't know if you can run Windows 10 inside of Docker at all, but you can run, you could run emulators if you wanted to, but, Wine, which stands for Wine is not an emulator, which I think is hilarious. Wine is a recursive acronym, right? Because Wine is not an emulator, which stands for Wine is not an emulator, which stands for Wine is not an emulator. There you go. All right, all right, all right. So where are we at? I'm missing stuff. I'm trying not to miss things, but yeah. So Mangler, strictly speaking, you only lose 2 for the networking purposes. That other one that's lost is still a host. He's just a host that's necessary. So we yeah, we'd be like down here like splitting hairs. We'd have a hair in our hands and we'd be cutting that in half for whether it's 253 or 254. But from a networking standpoint, you only lose 2 for that reason. Everything else is, I mean, technically you don't need a gateway because technically you don't need to ever connect anything to a network. A network can just exist. All right. Anyways, but that's being silly, of course. So let's go look at SS. SS will show you all kinds of cool things on your system. So let's make this a little bigger so we can see SS a little better, and make that just a little smaller. I have to make it a little smaller, and just a little smaller. Guys, I apologize. It might be too small for you to read. If you want to read it, you might have to read it on your own screen. So let's use our SS. And now, just at face value, we've got UDP up here and TCP down here. So ports are mapped at layer 4 of the OSI model, which is called the transport layer. You have 65,536 total UDP ports and 65,536 TCP ports. Now, you take 2 off for those as well, but the point is, if somebody tells you, tell me, like enumerate for me, like a security engineer says, tell me that you've locked down this box or hardened this box. So this is, so explain to me how you know this is secure. Well, you can say, well, at layer 4 of the OSI model, I am only listening on UDP to this traffic, and I am only listening to TCP on this traffic. And they say, yeah, but what if somebody breaks through past that? And I say, well, there's nothing on my system to even listen for it, so there's no vulnerability there. There's no, it's not bypassing a firewall, it's an inert port. It is a port that is not being listened to at all. So this is part of our hardening of systems, like we close down the number of open ports. But then there's all kinds of other things that we can know about it. UDP is always unconnected unless it's actually being run, but UDP is basically just sitting in a listening state because it never actually goes to a connected state. Whereas TCP down here is listening, and then there's a 3-way handshake, and then it's a connection-oriented protocol where the communication happens in a sequence and acknowledgement order the entire time. Everything's sequential with TCP. Nothing is sequential in UDP. They just launch data over. But look at all this other information. I can see if data is being received or not, and then I can see the local address that I listen on right here. And the local address, this tells me that I'm only listening for 127.00.53, which is my local machine, and 127. This is 172.31.2, which is my local interface. So these 2 ports are not exposed to the world. They're only local ports for my system. These 2, however, or these 3 right here, however, they're listening to any IPv4 address that wants to come in on port 68, and they're going to do whatever DHC client actions can happen to something that properly connects to port 68 on this box from anywhere. So if that is deemed as something that doesn't need to happen, like I don't need to be a dynamic host configuration protocol DH client, then I should work on getting rid of these. I see the process IDs right here that are running them. I can go close those down if I want to, right? We're not going to do that right now, but it's possible. Down here for, and then, yeah, so that's all the UDP. So we know we could enumerate and talk to our security team about everything that's happening in our network that's UDP. Right there. Down here for TCP, we can see that our system is listening to anything IPv4 coming in on 40200. This is this KC terminal program. This is how the internal labs communicate. That's how that all kind of works. This one is only listening locally on 33577 for container D. So container D commands can only be connected to from this machine. There's that. And then Sa, I don't know how to say that. I'm just going to call you Sa. There is a, down in our Discord, if you want to go ask in there, there's a whole bunch of networking topics and stuff for people that do networking stuff. So let me link the Discord if anybody needs it. You just might find more people responding to you down there as far as that goes. And I'll go put it over here on the YouTube side as well for people that are interested in that. Remember, we do labs on Sundays. That's all we do on Sundays is lab days. But maybe the specific question comes in, and we could keep looking at all these, but the specific question that comes in from somebody is, are you listening on SSHD and are you listening on Containerd? These may be questions that come up. So yes, we are listening to SSH. Here's SSH right here and SSH, and I'll tell you the difference between them in a second. But there's Containerd, like we described earlier. And you might say, well, I don't know much about Linux, so what did you do there? Well, this was a raw dump of everything that is listening. So SS with N will be to not do the name translation. I want to see the port numbers. T will be transport, TCP, and U will be UDP. L will be, I forget exactly what L does, and then P, but we can always read the man pages on it if we need to. Here's our L is listening, yeah, if they're listening. N is numeric, don't resolve the names, that's what we wanted. P is processing, yeah, we want to see the process socket, it's very important. And NTULP. T is TCP and U is UDP, so there we go. Yep. Yeah, so that's an answer to all the things that I was looking at there. NTULP. But you always go read the man pages if you can't remember stuff, right? So we carve it down, and here are the two things, SSHD, Containerd. These are the two things they're listening. Containerd is only listening to localhost, so he's safe. SSH is listening to anything, that's the wildcard for IPv4, to come in on port 22. And this is anything IPv6, that's the wildcard for anybody, on port 22 of IPv6 as well. So my system is listening on process ID 637 for SSHD and process ID 595 for Containerd. So then I can say, is it listening? And it will say, yes, it was. Now we can go look at these individual ports. This is one of my favorite commands. Like, this is like if I'm trying to find out, like I'm coming to a server later that maybe got compromised or we consider it might be compromised. I'll do stuff like this and I'll look at the port number. I'll make this a little bigger again. I'll look at the port number, LSOF-I port 22, and this is what's listening, port 22 of our box. This is also the file descriptor if we need that. But for now, there's the process ID. I should be able to map that back. So if I do an SSH dash, well, we could do this too, watch. We could go ps-eo lstart cmd and maybe pid. And then we'll grep for 637, right? And there is the process ID here and that was started as user bin ssh-d. And then we can go find, also, lstart. Let's do also its parent process ID. So what's its parent process ID? That is 1. And I've told you guys before, I said this earlier if anybody was around, that if it's 1, that means systemd started it. Yeah, O allows you to pick your particular options. So you've got a whole bunch of options. If you've never messed with that, go man ps and go look for your options down here. They are right. Hold on. I look at these not all the time, but somewhat regularly. You can see them there, but they also are down. Hold on. Format is here they are right here. So here are the things. Yeah, so you can see PID or R for real user. You can rename them if you want to. Hold on, wait. They should have a default of all of them. No, hold on. I missed it. Because it's got there's some of them there, but we have all of them. Here's the individual ones. You can see them here, but there's a list of them. Hold on. Yeah, well, here's a bunch of them. So PID, TID, class, RPTIO, you can find a bunch of them if you want. But I like CMD tells me how it was started. Parent process ID, PPID tells me like what called it. But there's a whole bunch of examples here. And then, you know, you just pick up the ones that are useful to you over time. For me, this one with lstart and CMD is when exactly did it start? Did it start when the system started, or did somebody start it later? That's useful for me. I want to know that. If I'm coming to a box and, you know, I'm getting called out in the middle of the night, I want to know, like, and the server's been up, let's say the server's been up 30 days, but then I go see that this process was restarted a whole bunch in the middle of the day. Well, then now I know I'm probably dealing with some lingering problem some other engineer was dealing with earlier in the day, or some other person got a ticket. So I'm going to go back through my team's closed tickets, right, before I have to go call other people out. Now I'm going to find what was happening to that box that somebody was restarting this process over and over again. Does that kind of make sense? But this is like, I hate to say like you're doing forensics, but you're finding stuff and you're proving stuff to yourself about how the system's behaving and working and all that stuff. So, did I miss anything over here? I don't think I did. Okay. So, we could also do that same thing, that LSOF. We could also do it right here for 33577 and see that that is only listening for localhost, but it's this PID 595, which is also the one that we found here. So 595. So then I go and I say, well, I know this was started by systemd and it's SSHD. So maybe if I did systemctl status of SSHD, I may see that this is the SSH server. I see that it's enabled. I see that it's turned on. I see its main process ID is 637. Can I map 637 to right here? Yep. Can I map that to the listening port right here? Yes. Can I map that to the listening port I saw up here? Yes. Right? All these things will tell me what is exposing the ports on your system. It cannot be. Let me just explain something that cannot be. You cannot come to a server, do an ss-nt-ulp like this, and not be able to figure out what is opening a port on the server. That is like some fucking CSU stuff where they're like, I tracked them by their MAC addresses back to their wherever, and you're like, oh, motherfucker. Or I hacked in on a non-open port on TCP, and you're like, oh, motherfucker. Right? Like they do that for the crime drama of it, but it's not real, right? So, anyway, so let's go look. We can connect to our system, and we'll see. I did a little timeout 3 on the front of it, so that we could connect to our system on port 22 and see that we get an open SSH header. Yeah, CSI, whatever, or Criminal Minds or whatever bullshit. One of the ones that gets me, like I was watching Law & Order SVU recently, and I've watched seasons 1 through 12, and I'm pretty sure I'm done with it. But the thing that they always do when they show IP addresses, they always have they're 4 characters dot 4 characters dot 4 characters, and I'm just like, or it was an untraceable source address, and you're like, well, then how were they sending? If it was an untraceable source address, how are they getting the packets back from the camera they were watching? So you're saying they used some bullshit source address? Well, how were the packets coming back from the camera then? Doesn't make any sense. To communicate, you have to communicate, right? It's weird. But anyways, I don't let that stuff bug me that much. I'm just pointing out that that's a thing that you can look at and go, I know better than those people. Anyways, all right, I'm just kidding. But anyways, so here's this. We see the 595 that we expect. We see that it's enabled, meaning it's going to start on runtime, and then we see that it's running. Now, you might say, as some astute people do, they say, wait a minute, Scott, you told me it was enabled here, but then it also says enabled over here. Which one am I to believe? Ha, 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 ha. I got you. No, this is what the vendor preset was. So this could have been enabled when you installed Containerd, but you could have disabled it later. So this is the current setting in the system, enabled or disabled here. The vendor preset is just the way you got it when you installed it or when you ran the installer script or whatever. So the things that matter to us are, is it enabled or disabled here, and is it active or running here, or is it active or dead? Those will typically be your things. All right. Anyway, so hit Q, get out of there. And then we might stop Containerd, and And then we can look at the status of container D, and now it's dead. We see that it's enabled. It would start if the system booted back up, but now it's dead. So now we should not see container D in the output anymore of SS. And we can do an SS without it, just to kind of make sure that we're not lying to ourselves. But no, container D is no longer on there. This right here is just like, it'll check it for you. So this is us eyeballing it. And eyeballing it's fine, even if you have terrible sight like me. Eyeballing it's fine until this is like 10 pages or something. So what we do is we use grep to filter down and see, is container D there, right? So it's just an important filter tool for us. Would stop and disable enough to prevent it from starting again on reboot. Disable would stop it from rebooting. Stop would only stop it in this instance. You do not need mask. Nope. Nope. So these are toggle. These are toggle right here. If you do, if you just disable, that'll be disabled. If you do stop, it'll be stopped right now. But you have to do them as they're, well, you can do it at the same time. But if you mask it, it'll never come up again. Yeah. So you can mask things as well, and they won't start ever again. All right. So we go over here and we say, let's check network traffic. So let's see how the traffic's actually flowing on our system. So now, so what ports are we listening on? Many UDP, many TCP. We checked SSH. We checked, maybe for our notes, we just say we checked container D. And then maybe we stopped container D, just for fun, right? Those are the things that we kind of did in this lab, right? These are kind of things that we can answer for ourselves. Now we're going to look at traffic, so I'm going to back out even one more, and I'm going to say traffic. Is the system under load, right? And I'm just going to ask some stuff about the system. So let's look at network traffic. Let's look at the throughput of our interfaces, and let's make a little PCAP that'll capture the packets of our system, right? So we'll do an ifstat 2. So every 2 seconds, for 10 seconds, we'll look at how many kilobytes per second in and out of our interfaces. The reason I say kilobytes is that's a capital B. Do you guys see that? But the interface, the actual line speed of a network is always in kilobits. So what does that mean? That means for you to figure out your kilobytes back to bits, you actually have to divide this by 8, whatever this number is, right? And that's how many, and then, well, this is 1,000. So you got to multiply this by 1,000. Then you got to divide it by 8, and that's how many bytes per second you were getting. But suffice it to say, you are not using very much on this primary interface right here. Not very much traffic coming in or out. That's good to know. Then we can go over here and we can just TCP dump this. And TCP dump will very quickly hit 10,000, which is the, whoops, hold on. Clicked on the wrong button. You guys are seeing under the, you guys are seeing behind the ignore everybody behind the screen, right? Right here, now this is a TCP dump. We're looking at that interface. We're looking for the full packet size. S0 means we don't limit the packet size any, and we want to count the first 1,000 packets. The reason this happens so fast is because this is responding back to us, and then we're basically generating the packets very quickly, right? There were 75 packets dropped by the kernel for whatever reason. They weren't being allowed or whatever, right? So now I can go and I'm going to generate a PCAP, but I'm going to do some pinging during it so it generates more. So we're going to generate some lines as we go. Those are happening in the background. There's a whole bunch of pinging happening in the background. And then we had our 200 packets captured. And then we generated a PCAP file. Let me show you guys this real quick. We generated a hostname.pcap file. And if I ls in here and I go look at more ubuntu.pcap, we're not going to be able to read it, right? It's not in a format that we can read. So what we might do is ls-lh for root ubuntu pcap, and we can see that it's about 21 kilobytes long, and then we should hit check and it'll be good. What you can do with this pcap file You might say, well, why would I do that and generate this PCAP file like over time or whatever? The reason we do that is there's a free tool, Wireshark. You can download this tool for free. And then you could load up any of those PCAPs. So I'll show you guys one that I had done before. Let's get out of here. I don't need that. One I had done before from like my, I think one of these was these are older, look, these are kind of old. But I had one, yeah, my Kali box. Now I can go look at it and I can find out, is my Kali box communicating to the different devices that I expect it to? Or is this ARP broadcast asking for who has this IP address and then telling 192.168.11.193, tell that machine what it is? And then the broadcast is happening at, in this case, the MAC layer. So the source and the destination are MAC. And you guys should know this. If you don't know this, I'm going to tell you. The broadcast of any network is always all host bit 1s. But the broadcast of a layer 2 address, which is an Ethernet 2 address, is always all Fs. So the destination, if I want to broadcast to everybody that can see my LAN segment, I broadcast in all Fs. So that's 4 1s, 4 1s, 4 1s, 4 1s, 4, 4, 4, all the way to 48 ones in a row. Say, how do you know it's a bunch of ones? Well, because they're hexadecimal, and an hexadecimal F is 4 ones in a row. It's the highest number. It's 0 through F. F is 1 1 1 1 in hex, right? Right, and we're not doing that right now. We're not doing the networking portion, but my point is I can come in here and I can see what my system was doing. This has been useful for me where one time we were updating the way that our backups happened with a bunch of my Linux boxes, and the storage team was a separate team. They worked with the VMware team often, and then the vendor were on, and they were like, this system, we have all the connections set up. He's simply not sending the data over the pipe. So we need to get down on the Linux box and run a TCP, like a TCP dump of everything that's going out of the interface. So I did that, and I filtered for the traffic that they expected, and they never saw it. So then I filtered for all the traffic of that type, and I saw that things were going a different way. And I said, well, that's weird. Isn't that the old interface? You guys have given me this new IP address range that we're supposed to be going to. And what they found, this was actually kind of funny, sitting on a call with a vendor who has assured us that everything's configured right. And they're like, wait a minute, go into this config, this, and this. I said, all right. So I go to their config, and they're like, can you change this for us? And I'm like, yeah, I'm root on the box. I can do whatever. Now, I will do that one-off for people on a box to verify something works. But their deployment of it has to do it themselves, right? I'm not gonna go fix all that, because then I own it, right, for some vendor, and then not even just for the vendor, but for my team that needs that in the future. No. But what I did was I fixed it because somebody who had originally come in, one of their pre-sales engineers, had set all the stuff to the old one for testing. So all the traffic was still going out the old pipe, not to the new one. Set it, everything worked, and then I could watch my TCP dump the traffic go from the wrong way to the right way. That's why we have to do this stuff as systems engineers. You might say, we're doing the low-level engineering. We're not the ones that have to know that. Yeah, we do. We're accountable for what leaves and enters our box as a systems engineer, as a, whatever. And you need to know how to use your tools. You need to know how to, so you can man TCP dump. And when you go in here, you will not find any useful filtering in here. But if you get all the way to the end, this is one of the reasons I tell you guys you got to know your tools. You got to spend time with your tools. Get all the way to the end of this. There's all kinds of networking crap in there that I'd learn my networking separate, right? I wouldn't learn it doing this. But there's all this stuff, and they start talking about like being able to go by source port or destination port, but then they don't really give you much about how that works. So then you come here and you go, well, hold on, there's these references, and the references go to these other things, and the one you want to reference is PCAP filter. So they'll give you some TCP dump examples here, right? Right, and they'll say, okay, I can do some TCP dump and I can do whatever. Nope, go like this. Now man PCAP filter, right? And in PCAP filter, there's all this stuff here. This is where you actually get to destination host, source host, host Ethernet destination, destination gateway. If you want to track and do filters by source or destinations, these are your PCAP filters that apply to TCP dump. Destination net, give me a full net and give me that network with a mask after it, right? How do we want to map that network? How do we want to do the source network? So anything from this network going out or through this box. Maybe your box is functioning as a router. Some of you guys might have been around when I was building this box. There's a server here in my home lab called cRouter. And cRouter sits between two networks in my environment. He's got two networks in his hands. He's like a short circuit for my environment. He sits on the 192.168.11 network. 192.168.11.0/24. And on the other side, he's got a 192.168.200.0/24 network. And he's the bridge. He's the only way traffic gets in or out of those two networks. So if I want to verify that traffic is flowing from these Rocky boxes that are down right now through to my other network, I can go do TCP dumps on cRouter and see the traffic. History, grep-i TCP dump. So here's different TCP dumps when I was looking for source hosts through destination hosts and different hosts, and I can do the networks as well. But you can filter how traffic is flowing through your network. That's if you're, in this case, my system's functioning as a router. Linux boxes are still good routers nowadays, but a lot of people don't use them for that. There's enough devices out there that you don't really need to go set your Linux devices up like that, unless you want to be the network engineer. I would advise people that want to do systems engineering, stay out of that space. Unless that's something you want to do. All right, anyways. So look at you learning Linux. You did all the traffic stuff. You kind of figured it all out. And then we looked at what's happening there, right? We did all that. So is the system under load? Not heavy load. TCP dump showed SSH traffic. That's all we had going in and out of there. And then maybe we had some, I don't know, what do? We did ping traffic worked out to Google, which means that we resolved DNS and all that other stuff as well. There's that. I missed to follow the alpaca. Hopefully this stuff's useful to you. We are, well, man, we're almost on 3 hours right now of like systems stuff. I got asked to do the basics, so I started with the basics today. And look at my notes. I took all these notes about the different labs we were doing. You guys have the labs there. If you want to do them, they're on Killer Coda and they're free. Look at that. Look at all that kind of stuff that we got. Yeah, PCAP files. Then you just, all you got to do then is move them out and then open them up in Wireshark. Wireshark also has, if you're running Linux boxes that have GUIs, you can open it. Wireshark will open on a desktop for what's it called? Like if you have a Linux desktop, but I don't run Linux desktop. I've only run that a few times in my career. I ran Linux all through college. I think I told you guys that for my home desktop, but then I kind of got out of that. Yeah. Alpaca, yeah, the Wireshark is such a good tool to understand. I'm always telling my systems engineers and, well, mostly my network engineers at the college, I'm always telling them, like, you've got to get in that tool and you got to feel comfortable using the different pieces of it. You got to get comfortable looking at what traffic is good and what traffic is not good. What does a preponderance of errors look like? And over a certain amount of time, those kind of things are super useful. Zeek or T-Shark? Nice, Doc. I think Zeek, wasn't Zeek just a front end? Oh, no, I'm sorry. Zeek is that monitoring. Yeah, hold on. We had Zeek set up in one of my networks before. Zeek. Source. Yeah, Zeek does all your network security monitoring. Formerly Bro. Zeek and Ye Shall Find. That's a pretty good one. Been around since the 90s under the name Bro, and then it got pulled up, and people are using it. Look, I happened to use it at a big college, big university that I was working for a while back, and it feeds up into your SIEM type tool, which is your Security Information Event Management. All right, there are good tools out there, guys, right? There's a bunch of different stuff you can do, a bunch of things you can play with. All right, so if we got 4 done, we're getting there, right? We're getting through all this stuff. We'll pull up a fun one here. I'm gonna have us do the NFS one next, but not because we're actually doing NFS, but because we're going to use that lab for a different lab that I've kind of put together. I'm actually curious what happens with some of the stuff that'll work in there. But yeah, let's take a little break. We'll keep an eye on Ranger Dog, see how Ranger Dog's doing. If anybody, go take a break if you want. Let me pop it on to, hold on, put this off. Ranger cam, there's Ranger, and I'll put my little hourglass up, and I'll say take a break, then more labs, right? Because we do labs on Sundays, guys. That's what we do. We do labs, we take notes, and we keep our notes over here. I'll be back. All right, man, my break. I just walked around. I still got 5 minutes. All right, I guess I'll be back now. We're gonna do another lab, and then as we do the lab, we'll mess with some different parts of things. I think I'm gonna put together. Let's see what I got going on here. Oh, we could do some of that too. But I've got a lab that I never finished putting together. Oh, I put it all the way over here. Yeah, I've got a lab that I never finished. Let me grab this. Socratic Linux. Move this all the way over too. Because this, by the way, these Socratic Linux answers are up in the Discord. So if anybody wants to do any of those types of questions, you can. They just have a bunch of things that you ask yourself and then you go figure out how to do inside of a Linux system, right? Kind of, learning the tool, learning how you can do things and look at different pieces of things and kind of hold it. I always tell you guys, like, holding it in your hand and like grokking it. Grokking is the idea that you like understand something fully. So I know it's an AI term. I know it's something that, you know, people like or dislike Elon, and I know he uses the term a lot, but grok has been around in engineering for 40 plus years. Whenever that book was written about the Martians with the grokking of things, that's when that term came around. It's been around a long time. So longer than I've been in engineering, that's for sure. But anyways, the point is, like, you kind of figure out and hold the thing in your hand and understand how to do it. So, all right. One other thing. While we're sitting here waiting, since we're still on break, I'm going to pull out a different thing here. We'll leave this down here on NFS because we're going to use the NFS one for this. But let's go here. And I want to show you guys in one of this is the only thing I get out of Killer Coda, in case you guys are wondering. You're like, oh, what does Scott get for this? The one thing I get is if I go to like my Het Tanis labs here, I get to go to activity and I get to see how much people have been using the labs. So I got the past hour, like, was anybody using it? Maybe a couple people checked in with me and did stuff with me. Here's the last 24 hours, but then the ones that I care about are at the bottom, but we'll go down there. Daily scenarios for the last 7 days. People have been using them, so that's cool. What's a popular one? Installing Ansible was a popular one for people that haven't done Ansible. Here's the last 30 days. There was probably a spike on, if I had to guess, this spike was August 19th. What was August 19th? Monday. Maybe I was on real long on a Monday, but that tends to spike like that when we're doing labs together. And then here's the past 6 months. And we used to average way down here in like the 2000s, pretty low. And then when we kind of like, there was like kind of a big thing on YouTube where I don't know what happened. One of the videos like people found and they liked it. I don't know why it was in the algorithm, but we had like a few 100,000 views on a video and it shot us up to a lot of people were doing the labs. Now we've been kind of dropping off, but the drop off also has been me not focusing on doing labs as much in the thing. So when we do labs, we should be getting more people in here. And then you can click on them and you can go, oh, look, people have been doing the Stigs and the Firefox stuff, right? So double click. Somebody did 6 of them this month because these are newer, right? These are newer ones. And people were doing the Stig and the Firefox Stig scan. So if you want to know how to Stig a box and do that security stuff, you can do that. All right. Anyways, that's one of the things that's like all I get out of this. I mostly do this stuff for fun. Yeah. So we'll do a lab we'll do the NFS lab for fun, and then we'll go and we'll actually like kind of take it off the rails and do some little system speed testing and speed, verification type stuff that we can do. So this is a good lab for the NFS one because you'll be able to see very clearly the difference between some of the things that happen in the system. And then we'll pull up our notes and we'll let's call this one, this will be NFS lab with speed testing, right? Maybe this one will be fun for people. All right, I'm going to pull this lab up here. And then I will link the lab for people that want to do it over on the Twitch side. There it is pinned on the Twitch side, and here it is on the YouTube side, although I'm not going to pin it because, again, their pinning thing is maddening, their UI. So let's get out of here. Close that down. And I'm going to make this a little bigger because that's fine. And let's go and let's mess with our systems a little bit, right? Like, because one of the things we do, like, we build stuff as engineers, and, like, it's kind of boring. Somebody on some team needs NFS. They need, a team has determined they need NFS to share and facilitate file systems across multiple servers from one central location. Your team figured that out. Somebody on your team figured that out. We needed to, share storage, right? So you're going to deploy an NFS server on 2 nodes, or you're going to deploy a server on 1 node, and then you're going to connect to it from another node. That's what we're going to do in this lab, right? Then when we're done with that, we're going to test some speeds, because you've probably heard before that NFS is not a super high-speed file system. It's not really. But let's see what the speed difference is, right? So we'll do a little bit of speed stuff, and then we'll also do a little bit of networking speed testing as well, because now we've got 2 nodes. We've got this one and node 0, 1. So now we've got 2 nodes that we can ping pong data off of, right? To see, because again, the boring thing is building stuff for everybody. The fun thing as engineers is hitting the little gas pedal and seeing how fast our thing can go, right? Could you imagine you're just like the engineer that like builds the car and you're doing all this cool stuff and making the engine better, but then some other engineer just gets to sit out there and drive it around on the racetrack for fun? You'd be like, well, can I do that a little bit too? Like, that seems fun. But anyways, we all have our different roles to follow as engineers. But my point is, a lot of times as systems engineers, we don't really get to step on the gas. We just build stuff because somebody needs it. But one of our things that we should understand is how to baseline test a system. How does our system operate? What happens when we spin it up a little bit? So let's do that. So let's do the lab. The basic lab is we SSH to node 01, and we look to see if there's any NFS packages there. No NFS packages. Okay. So we'll install the NFS kernel server, which is the server for NFS to run. Product and engineering gets to step on the gas. Yeah. The guys later on down, the pre-sales engineers get to step on the gas a little bit. But you can look at what this is doing. This is creating systemd type things that will start up. There are systemd services and targets that will start. Then one of the things it's going to do is it should restart the systemd daemon. We should actually see that. But it makes a service right here for how NFS starts. And then it process triggers for systemd, meaning it restarts systemd. And I should now be able to say systemctl status nfs-server, right? And see that the server is running. We also see that command right here, so we can just run it. The command shows that NFS service is running. It's listening. Its main PID is 20166. It's enabled, so it'll start up when the system starts up. It's active right now. It's got a process ID and it's not dead. That 20166 process ID should technically map over to how we started. So here's 2049. Why is that not? I feel like that's not showing everything. But that is 2049 is the primary listening interface. So we're listening on UDP and TCP for NFS connections. So there we go. Come down here. We see that it's listening on both TCP and UDP, even though there's no shares. Do a show mount -e, there's nothing being exported from this box. We're going to make sure the firewall is off. We're just doing that for now. We could set the firewall service if it was on and allow the connection, but for now we'll just leave it disabled because it's disabled. And we're going to make a directory that we can share out. We're going to call that directory share, and we're going to give it the permissions nobody and no group. So when we do an ls-ld on share, you should see that it's owned by nobody and no group. It is a directory right here. It is 755 on permissions with the nobody and no group as the owners, and it's /share right there. Good. Then we can go to Etsy exports. I can hit Shift G and O. Shift G and O. And then I'm going to add this line right here, /share to anybody, read write, sync, and then, sync, and then no subtree check. It's fine. And those are all, hold on a second. Just realized that wasn't running in the background. All right, is that better? Can you guys see my words now? All right, I don't know when that stopped working, but okay. So what did we do? Escape :WQ, and then we are going to restart the service and do a show mount -e, and then now we've got the share. So what did we do? We SSH to node 01. We verified no NFS server, installed NFS server. We created a share, added the share to Etsy exports, right? That's where we did it. And we can say a share of /share, right? Added the share to Etsy exports, and then we restarted the NFS server. service, and then we verified that /share is being shared via show mount. I think I can do. Actually, you know, I'm gonna start doing that. I'm gonna start doing the backticks because I like when it does like the little coding thing like that. That's kind of nice. Okay. Because it is markdown, right? This is all markdown. All right. So we did that, and now we've got that on the one side, and then on control plane. So on this, we set up NFS server. That's what we're doing there. On control plane, connect NFS client to node 01 server, right? So now we got to connect the client. So we got to do this next part, right? So we exit back out, and then we'll see ourselves on control plane. And we go to the next part of the lab. It says, so far you've set up an NFS server and share. Now we have to connect to it as another system. So if you were taking notes, those are generally what you just did on that box. Like if you were trying to do this and then kind of close your eyes and say, okay, I want to be able to do this, you know, without this video and without this lab. I want to be able to install this on like my home lab. What did I do? I made sure that the software wasn't there. I added it. I turned it on. I created a share. These are the things we do as engineers, right? We got to understand how to install things, how to turn them on, how to verify what's going on with them, right? This is our life. Those options in the export file, what do? They are the default options, for that matter. But hold on. Let's cat exports, and I'll tell you. We're gonna let it be read-write, so things can read and write to it with the right permissions. We can the client chooses to sync or not, but it has to be allowed to sync. And then sync is I think on the client side we do no sync, but I might be wrong. But the client is allowed to sync, meaning the client can check and update things if it wants to, or it can just sit there open without sending messages, right? So there's like some syncing options and whether or not data is always flowing. And most of the time I think clients leave that off for performance reasons. And then no subtree check means it doesn't have to go and walk the whole system every time. And there's a whole bunch of options that can or can't be there. These are just ones that were explicitly given. There are other ones that will be given by this file when we actually go and mount. The one that always overrides, and I always ask this question, what do you think overrides if you set something here on the server and the client wants something more permissive? Who do you think wins that? And I'll ask you the question another way. If you go to your friend's house and they say, hey, we take our shoes off around here, and you say, I don't take my shoes off ever, I've got a policy on it, and they go, well, we've got a policy that if you want to be here, you've got to take your shoes off. Who do you think wins that? Right? It's the server, right? The server always wins on a configuration like that. All right. Let's go back out. So, okay, so we'll go here. We'll look at how this mounts here in a second. So we've set that up. Let's install it on this node, the client. Now, I didn't show this time, but when we install the server, were there dependencies, right? And then on control plane, we install the client. Were there dependencies? Oh, well, let's get underneath as well. What I mean by that is this. I only told this thing to add one thing, NFS common. But the apt package manager knows that I want the end state to be a NFS working client. So it added all these other things. And how we can find that is we can just like tail -5 maybe on var log apt. Maybe it's dpkg log. And this should show us, I thought it was apt log, hold on. Yeah, apt, and then apt log. History, there it is. So it's apt log, history log, right? And right here, I said to install this, but look at all these other things that were dependencies that needed to be there. And back in the day, you might say, well, how did we do it back in the day? We had to go find all those ourselves. or it had to be packaged already, and then we had to build it. Installers have made our lives greatly easier, but from a security standpoint, they could be introducing all kinds of other things over there. There's all kinds of stuff that could be popping up in there. Yeah, Cuddlingus, we still use NFS. Yeah, NFS is the main reason we use it for typically is to have a back-end storage of like configs. A lot of times we'll have config information that can be pulled out of there. It's not a high-speed storage. You're gonna find that it's much slower than disk speed. It's much slower than like some of the API type stuff that's out there, where you just look at the objects and stuff. But it's pretty good for document level stuff like files and configs and type stuff. And I use it for mounting everything and then pulling Ansible configurations and letting a box configure itself. That's what I use it for a lot. Yeah, it's still very valuable, Cuddlingus. And then on the up in AWS, we use EFS, which is just NFS rebranded as Elastic File System. And then as servers come up, they can be connected and grab whatever. NFS and backup storage setups, usually in quite controlled environments from a security perspective. Yeah, and we can lock down who can connect to the NFS, and we can do all kinds of things, especially NFS version 4. There's a lot of kind of newer stuff that's available. So now that we've got this, we're going to test a mount. We're just going to test that we can connect over there. That command will mount node01 share 1 mount to /mount in our system, so it mounts from there to here. And now if we just do the mount command and look at grep for /mnt, we'll see that we mounted that share at /mount. We've got a type of NFS version 4, and these are the only things we said. RW, where was it? Sync and one of the other ones. But look at all these other things that came in there by default, right? Look at all these other things. We can look at df-h on mount, and now we see that it's no longer this local file system. It's over there. And then we can also touch and make a file over there and look at it and see that it's got nobody and no group. It was written with the permission 644. It was not written as the root user. Root did not write it. It was written as the nobody no group. So that's an important thing to understand for this. We're going to unmount it, because just unmount it. And then we're going to go add that into our etcfs tab. So I'm going to say maybe added for lab. You can put nice little notes in there, and we can grab this and then Control-Shift-V. And now what we have is the node01 share over here. We're mounting it to /mnt via the NFS file system type. The defaults are just the defaults. It'll accept whatever defaults the client and the server negotiate. And then 0 here is do not ever run an FSCK on it, and do not ever back it up. That's what the 0 and the 0 are. Mount-A is this old admin trick where I just say, okay, go read the whole system, and if there's anything in etcfs tab that needs to be mounted, go ahead and mount it. And if I do that, and I do a df-h and I see that that's mounted, that means my etcfs tab was configured correctly. Because if you recall, I had unmounted it a few seconds ago. I did a umount-l on mnt, and then when I did a mount dash, so look, we do a df-h on mount, and it's local, and we do a mount-a, so we read the etcfs tab, and we do a df-h on mount, and now it's there. So there we go. So were there dependencies? Yes. Were there dependencies? Yes. Yes, many, right? There were many. So then we say mount. So then what did we do? We installed the client. We mounted manually. We made a file in /mnt to verify it worked. Then we U-mounted the file system. We added mnt from node01 share in etcfs tab, and we did that like this. By this line right here, right? And then we did a mount-a mounted to verify from the etc fstab file, and that looked like this, right? So we did these kind of things. Asterisk better than subnet, doesn't matter. Yeah, Doc, I was just asterisk was everything. I could have done just the subnet and been more secure about it, Doc. So I could have in the etc or in the etc exports file on the server, I could have locked it down to just the one node too, if we really wanted to. We just use asterisk to be lazy, but it's good to understand why that was happening. No, so NFS is when we're sharing it remotely. ext4 is always on a local disk. AutoFS is a different type of FS, right? Or AutoFS is a type of way of mounting things remotely automatically, right? So let's keep going here. Let's touch a final check. And now that we've got a final check there, we've done the whole lab, right? We can hit the button and we could say, happy dance, we've done the lab. No, we don't want to be done. We're going to sit here for a little bit. We got 43 more minutes in this environment, right? And we're going to do some speed checks. Checks of the base disk. So the speed checks of the base disk, let's say, why don't we see how quickly our system here can write. So we'll write a little check here that looks like this. We'll say for I in, and then we'll just do, we could do 1, 2, 3 like this, right? We could do sequence 3. So we just want 3 little things to happen, whatever those 3 things are. We're going to say do, and then now with the do, we're going to execute some command 3 times. And we're going to do it, and then we're going to capture the output of it. So what do we want to do? We wanted to test the disk speed of the base disk of this machine. Or we could say of the, root disk. Right? And how do we do that? So we're going to do that, and then we're going to say dd in file equals dev 0. We don't want to be spending time on the processor with random. That'll add to our time for no reason. So we'll just grab zeros off the disk. And the out file will be root big file $i. And you might say, well, Scott, why don't you just write over the same file? Because sometimes file systems do funny things where they're like, well, this is a bunch of zeros and that's a bunch of zeros. I can compare them and I can save time. We don't want to save time. We are going to generate a new file system name every time. So it's got to do the activity again. Trust me, some SAN file systems will give you the weirdest stuff if you don't just generate a new file name every time. So do dd that into there. We're going to say block size is equal to 1024K and count is equal to 3,000. So we are making 3, we'll do 2,000. 3 2 gig files. Yeah, so dev random or dev urandom are good for other reasons, but those are going to cost processor time. So they're going to skew our system, our disk speed. We're carrying, in this case, we're doing what's called ceteris paribus. Ceteris paribus is holding all other things equal. We are trying to eliminate all the noise and say, just hit the disk. Just hammer the disk here. So I'm trying to remove things that would affect it. Because think about it. If I was doing dev random or dev urandom and this system was under high load, well, I might not want to test once under high load anyways. But my point is, dev urandom and dev random would take longer and they would skew our results. So ceteris paribus is this idea of holding all other things equal. It's a law term. Ceteris paribus is a economics term. We hold all other things equal and we freeze them and we only do the one thing we want to test. All right, so let's do this. This is going to work. It's going to write 3 times. And actually, when we're done, we can just say, just for fun, we can say rm-rf root big file $i, right? So each time it'll delete it when it's done too. That's fine. That won't affect it because that's happening outside of the execution of that. But this is going to write real quick, and it's going to give us 3, hopefully. You know what's funny? This system is faster than the other time we tested it, because the other time we tested it, we were in the 500 range, right? So I'm going to grab that and say speed checks of disk test 1, right? And that'll be all my test 1. And then maybe I come over here and I go, you know what? I don't really like... That's really funny that it... Okay. I don't really like, or I want to test that again, but I'm going to call this big file maybe dot test, dot test 2, right? And again, it's going to be deleted each time, right? But dot test 2, right? It's going to be deleted each time, but I want a second value of that test. It's cleaning up, so we're not leaving data out there. But now I can average these and go, okay. I can reasonably say, if I look at all those numbers, I'm not doing so many that I throw out the top and the bottom, but you can sometimes do that because sometimes they skew results. Would you guys all be okay with saying 760 average? Would you guys 760 megabytes per second average? Would you guys would anybody? I'm not like trying to get anybody in trouble here or yell at anybody, but would we all agree that that's probably fair to say 760 across those? Let's just say. So test 1 may be averaged to about 7. And I'm eyeballing it, guys, so I might be way off there. But we're going to use an average of about 760 MB S, right? And then all we got to do is make sure we compare like things later, right? And again, guys, we could throw them, we could do all kinds of things. We could put in Excel doc, we could do whatever. I would not send this directly to management ever, right? Because that'll be kind of messy. But now we've speed tested speed test 1 against local/file system, right? And I can add to these notes however I want, right? So that looks good. And I would say, there we go. That's about what we want it to look like. Okay, so now I say test 2 against NFS/MNT file system. And now we're going to do a couple tests there. I can just retool this to do my test, right? I can just go here to big file 1, and all this has to do is be set to mount now, right? We know that the mount is big enough because it's off the other device, and we saw that it had about 20 gigs. But now we'll do 3, 2, yeah. And we could keep track up here of how big. I have low matrices. I've shown you guys. Do I have this open? So hold on. When we do testing, when we do benchmarking specifically of systems, you do something like this, right? Where you have gather information, make your change, gather new information. You could distill these down into, whatever benchmark practical applications. This Linux system administration we sometimes go over, but we're not doing it today. This is up in the Discord if people need it too. So all my stuff's up in the Discord, right? You guys can grab it. Oh, I need to get this going because this is going to take a markedly longer amount of time to go through, right? We recall these. I want to say they were about 1/5 the speed, but maybe they might have been around 1/10 the speed last time. I don't remember, but we don't have to remember. We've got our documentation here, right? This is why. Oh, you did the average. Nice. There you go. I was just guessing. I almost said 775, but I was just kind of eyeballing it and saying, it's there's one low outlier. If I had more time and I really wanted to burn in against a lot of nodes, I might do like 1,000 of these checks, right? I might just let this run, cleaning up each time, and then I might take all of those and I might, out of 1,000, I might throw out the top 10, right? The 99th percentile and the lowest 1 percentile, because those may skew my results down. So I would look at like a histogram of it, and then I would figure out if I wanted to pull anything out, right? Because at the end of the day, oh yeah, look at this. It's that's significantly slower, which I remember that being significantly slower. But this is our test, right? Is there progress as a flag? Doc Mallet, there could be. Do you need the loop, Doc, for yours? I can link this to you. I know it'll be messy, but that's the NFS one. The other one is just change the mount to root, and it should work for you. Yeah, look at this. So we want to capture our tasty data. I remember this being around 50 megabytes per second, which is significantly slower, but now let's say, let's just discuss why I might be doing this. I might be doing this because somebody may have been talking about, hey, we need to go from NFS version 3 to NFS version 4, and we've found from the reading, right, because there's always the reading, and there's always the stuff that the vendors promise, and there's all these other things, but for me, this is one of my favorite expressions ever. I'm going to tell you guys this. One test is worth 1,000 expert opinions. What do I mean by that? We could sit down and calculate. We can go look at exactly how NFS works. We can calculate exactly how fast this should be. But why don't we just do a test and see how fast this thing comes out? This is what engineering is. One test is worth 1,000 expert opinions. And I love that. The guy who taught me that, the guy who I heard that from, was a aeronautical engineer. He did stress testing on planes and wings and stuff. And he used to say one test is worth 1,000 expert opinions. So now let's just say 2. Let's just call this big file 2. And let's get our second test of this, right? So test 2. So this is test 1, and it's 2 samples, right? We had 2 samples here. And then test 2. And then we're going to have an approximate speed here of whatever, which is going to be in the 50 range probably, low 50s, right? Confirm the network speed between the nodes to the level what you want it to be as well. Yeah, Alpaca, that's actually one of our next things. We're going to do some network speed tests. And we're going to see, because here's the thing. What is our slowdown? What is, as we start to find things out, and kind of in this case, we're almost just, because we're telling this, go ahead and write it as fast as you can, because that's what a file system does. So we're kind of testing what's the speed limit of this. Yeah. So, well, these are virtual machines that are connected on the same bus. So there you go. Too big to fail. I think you might have to put that on, or too big to flail. You might have to put that on Discord for me. If you pull it up on Discord, I'll grab it. Also, by the way, guys, we have Discord. You guys can go hang out there. There are all kinds of things going on in there. Look, people joining, which that's the main reason I do this, is to tell you guys that you guys can do stuff. Put it in general if you would. Look, people were doing Elasticsearch is back open source again. There's a lot. I get a lot of my news of what's going on in the industry from different guys that I know posting stuff in here. You know, posting what's going on and that kind of stuff. I hear a lot of stuff in here. We have a bunch of events coming up. Actually, there's an event. Oh, this event has already... Oh, this starts in 1 hour. So in 1 hour, Code Cove is going to be running. So, yeah, Elk is back, baby. Right? Pre-sales engineering, and then also our Linux system administration course is coming up. 16 weeks. I'm putting it together. I'm going to have some of the other guys help me with it. And you're going to do Linux. We're going to do a whole bunch of Linux. And that'll be there. All right, anyways, Discord is there for you guys to play with. Oh, did we run out of... Hold on. We never... When did I start this? So, I've had this happen before, guys. So, there's an interesting thing here. Did you see... I never hit anywhere near... We got to go back and check the VOD. I passed too much data between the two nodes, and it killed my session. And you might say, how do you know that happened? There's no way we just did an hour, right? We weren't in this environment for an hour. Yeah, I've actually seen this happen before, where when I do iPerf testing, it blocks me out too. I was actually worried about that. And I was looking to make sure that there was no... like ruling against it. We're not abusing the system. We're simply speed testing, right? We're not doing anything malicious, and that's an important thing to note here. But we don't want to do that too often. So I probably, well, okay, we can still look at this data and say, it was in the 53 range, right? But then the next thing we would do is we would go in here, let's say, and I'm going to go back and then we would do some iPerf. So this was speed checks against the disk, and then this was speed checks. Does that need to be out one? Yeah, speed checks against the disk. Wait, hold on. So move that back in, that down, and then say speed checks of the NFS mount, right? So this was this other thing. Yeah, so apparently you can go over the network capabilities of those. All right, but I guess that's a good behavior to find in there. Because I was going to do an iPerf one, but I was worried that we would go over the limit of what the bytes are that you can send. So you can just restart your lab, right? And we could keep checking those, but let's go ahead and let's go do the iperf stuff. So I have my iperf notes over here somewhere. Here's our iperf, right? And the thing that we got to do for this to work is we've got to set up iperf on both sides. So we're going to do an apt-y install iperf 3, and we're going to do that on both nodes. If you want to do it right on the other node, right from the same command, I'll show you guys here how you would do that with a minimal change. Like if you just want to stay on one node and go do it on the other node, here's the other way you do it. So check this out. When this is done, I'm going to wrap that in a single quote, and I'm going to say SSH to node 01, and this will go to that node, execute, and come back. So it's going to go to that node, it's going to put everything on it, and then it's going to come back to this node. All right. So now, when you're playing with iperf, right? When you want to speed test between two nodes, and again, we're only going to get so much out of this before the environment's going to think that we're pushing too many bits, which sounds like it's probably anywhere over 10 gigs is probably about where that blocked off or so. But you're playing a game of pitcher and catcher. I don't know if any of you guys ever played a game catch with your dad, or if you're on a softball team or a baseball team, but catch works like this. I've got a ball, I throw it to you. You've got a ball, you throw it back to me. That sounds fun. But when you play baseball, or when you actually play whatever sport you're playing, one guy pitches and the other guy catches, and somebody's in between trying to hit it, right? We have to set up one of these devices here to catch the pitches from the other one so we can test the speed. That's what we're going to do. So I'm going to go over to node 01 here, node 01, and I'm going to say iperf 3 as a server with an ampersand. And you say, why the hell do you do the ampersand? Well, because that's going to background the process so I can get my shell back. So now iperf is listening on port 5201 on this box, right? Oh, and by the way, if I exit out and then I go back over there, it is still running in the background on that, right? If it had died in server mode, we would have had to do a no-hup to it to start it up. But no, it's running. It's sitting there. It's listening. And it's listening on port 5201. That's where it wants the connection to come from. That's like it holding its glove and saying, throw whatever you're going to throw right here. So now we see the default port is 5201. And we should, if we were on node 01 again, we should be able to say ss-ntulp grep-i for iperf 3. And we should see that he is listening on 5201. Good. No hup will cause the process to not die when the parent process, which is my bash shell, leaves. So if we echo $, we see our bash shell, right? This is my bash shell, and if I were to restart, if I were to kill -9, this guy, watch this. Let's kill -9 that guy real quick, and then he's not running. Now he's going to be running, right? And real quick, if we do a ps-ef grep-i for 20624, right? Here's our iperf, and here's his parent, 20424, right? Just watch this real quick. Echo $, that parent is my bash. You see that? And if something is not properly no-hupped, when I leave this shell, when I type exit and my bash process goes away, all of my children die as like a zipper effect as I leave the server. Unless I no-hup. No-hup makes it so it's a no orphan kill, so the processes underneath do not leave. But iperf, when we started this like this, it must have set that because it didn't go away. So it's still there. So that's fine. All right. So now I can just do an iperf 3 and connect to node 01. And that's going to go and it's going to connect over there and it's going to send some, and it's going to tell me my bit rate of sending data over to node 01. Now, when I do that, I can see my actual bit rate here. I can see my full transfer in megabytes, right? And I can see what my bit rate was. Now, this is slightly different than the other stuff because we were looking at that in megabytes, right? This is our bit rate. We are sending 471 megabits per second. So if we take my calculator at 471 divided by 8, that is our, in this case, our throughput in megabits per second, right? And you say, why'd you divide it by 8? Because 471 is the raw bits, and every 8 bits is a byte. So that's why we divided it down like that. So it's approximately 58. So that is in this case, in this one send, this is only one transfer that we're trying to do. There's that. Now, we can add more. We have these different commands that I've added here. We can have more size that we're trying to send, and also more, I think, in parallel. So I can do that same command, and let's just add like N1000 and then like P5. So this will do 5 in parallel, and it'll send it over there. And now we started to get, our send was much higher. That's what our receive was. Yeah. Here's the sum of all of our sent bytes. And this should be our send and receive. Yep. Send, receive, back. And then we should get an aggregate of those. Anyways, there's a bunch of things that you could play with on these. But my point is I should be able to see exactly how fast things were moving in my network. I haven't looked at these in a while, but you're looking at transfers. You're looking at if anything was being received. Let me make this a little bigger, right? Sender, receiver, sender, receiver. So I did 5. I can see 5 connections there. That's the port on the far end, and this is my response, my port that was open for it to come back. And apparently I made that really small. I need to do something bigger. But if we keep going bigger, we're going to see this crash. The last two here are sums. Yep. Oh, these two are sums. Yep. Of our sending and our receiving. So interesting. So we can go one like this, and I think this will be the one that kicks us out when we do this, because we're going to go over, right? So now let's watch what happens here. There's our sum of how much we sent. I'm surprised this hasn't kicked us out yet. Maybe it's because we're not doing it all at once, but if we do one more, I'm pretty sure this is where I got kicked out last time. But even if you look at that and you say, Scott, I don't understand those numbers. I have to go spend some time with these numbers, figure out what's going on. I could at least look at these numbers and say, this is my baseline before your network change. And then I would have a way to say, this is my baseline after you did your network change, or after you dropped that firewall. You assured me that that firewall with port mirroring was not going, layer 2 device with port mirroring functioning as a firewall was not going to affect any network traffic. However, because of our testing, we found that we had a 6% slowdown. That affects us, and it affects our service level agreements, and now we have to shift everything within the internal organization. I hope you guys are okay with that, and people can get as mad as they want when you talk like that, but you're engineering. They're sitting there getting mad and being managers and shit. You're an engineer. You look at numbers. Does that kind of make sense? Like I tell people all the time, I don't have to argue with people. I just show them numbers. I just show them stuff. And I'm like, what I did was this before, and what I did was this after, and now when you guys are complaining about a slowdown, this is the one thing in between that changed, because we don't want to do this across multiple changes, because then ceteris paribus doesn't hold, right? Ceteris paribus. Ceteris. Yeah, that's right. That's right. All right. Anyways, iperf. My bad. iperf 3. This one's going to kick us out, I think. So now it's doing multiple of those tests. I think it's going to do it 30 times. And then this is going to end our session, I think. But again, I tell you guys, we're not doing anything malicious. We're just down in the system. Yeah, I think it's going to kick us out here soon. We're not trying to break things. We're testing the speed of the system. And here's our sum. That's a nice one, right? And we could drop this to lower. iPerf done. There's our sum, and there was our average of our send and our receive, right? For those, yeah, for what was going on there. 1, 2, 3, 4, 5. Yeah, for the 5 things that happened, here's the transfer and the bit rate, and then that's the total during the entirety of that run, the total sum. So, right, you can play with this. You can, any of these things, I'm surprised that didn't kick us out. And then you could grab that and you could say, okay, that's what it looked like on this command, right? This is what we saw within the system. We go grab that and we say network speed tests. And then this was speed test between 2 nodes, read, write. Right, this is a read write between 2 nodes, and then this is our approximate output, but I'm going to put this at the top because that's the actual command that I did, right? So that's the command, and then that's our general output, whatever, right? So, and then we don't need the iPerf done. Whoops, don't need the... I didn't want that. We don't need the iPerf done at the end. But this is our, and is there like a highlight? I don't know if there's a highlight in here, but that's the important piece. There's probably a way to highlight that in the markdown, but all right. So there's a lot of stuff, right? And apparently this one did not kick us out. Maybe it's because I don't know. Maybe there's something else going on. But I think if I ran it again, let's see if we ran it again. Get ourselves kicked out. But again, we're not stress testing the system for the purpose of stress testing. We're seeing what our speed is, and maybe over time too. Maybe the fact that we didn't do it all at once. So may also be if there's other load on the system, and then you trigger the thing that is causing the problems or whatever. Who knows? Who knows what's going on there? Yeah, there we go. We didn't get kicked out. So, all right. So, let's. I'm gonna hop off of here probably. If you guys are gonna do that event, that's every week, by the way. They're probably gonna start getting down in here. Oh, is this the article? Is this the article that got pushed in here? Too big? That's interesting. What? I don't want my window closed. I hate when they do this stuff. Like I have to have something to read there. It's like I hate paywall stuff like that. Got enough things that I spend money on. All right. Anyways, so you guys can go down the Discord if you want. There's events coming up. There's an event coming up in the next few minutes. Again, like I was saying, that's the Code Cove with Salty Catfish. He runs that. So it's starting in 34 minutes. We've got pre-sales engineering next weekend, and then the weekend after that, when I'm nice and back and settled from being in Austin, we're going to start our 16-week Linux course, which is, it's all the same stuff, but I'm going to have some worksheets. I've got some other stuff that's getting added into that. That's hopefully builds this stuff for you guys. All right. These were my notes. Do you guys want the notes? I'll put them up in Discord. But this is an important thing for you to understand. Like, you have this. Why is it not copying? Come on, copy. You guys have the ability to do the same things I did. I didn't do anything magical here, guys. I didn't do anything crazy. I didn't do anything that was smarter. Really? and do anything that was smarter than anything you guys could do, right? All I did was ask questions and figure things out. Now, granted, for some of this I had done it more, so maybe we could argue that I've seen it a little more. No, I'm using this as logsec, LOGSEQ. It's just a, some markdown note-taking tool. I think it's pretty good. I'll drop that up there. Yeah, I'm going to have fun in Texas, for sure. I'm going to be in a data center the whole time, not being able to hear anything. Where do I put that normally? Meeting notes, right? So I'll drop this in meeting notes. Boom. Oh, well, apparently it's going to have to go in like that. There we go. Oh, that's not great. Let's, I don't like that. I don't like that at all. Let me get rid of that. More. Delete. Deleted. Let's do this. This is what I sometimes do with, with these. Let's dump it in there. Control A, Control C. Huh. That is already text-based. Ah, well. You guys don't need it. You guys can remember everything. Alright. Let's go find somebody to raid. Let's, if anything's going on, you guys are welcome to hang out. I'll be down in Discord hanging out, I'm sure. But you guys are there. And let's go find somebody to raid on the Twitch side. On the YouTube side, I got nothing for you guys. I guess you just kind of hang out and then bounce if you want to. I've got nobody that I'm following that's on right now. Let's go find somebody of similar size in the same category. I don't see anybody doing Linux. Alright, it's going to be like last night. We'll just do it. We'll just drop. I prefer raiding somebody if I can, but I don't see anybody on right now that I know. So, alright, well then I will talk to most of you guys later. Take care.